Cool. I guess we're just gonna start because the beginning just some introduction slides. So good afternoon, everyone. Welcome to our first class of the Python Bootcamp 2020. So I'm trying to skip to, okay, cool, next slide. So, oh wow, is that an autoplay? No, stop. So this Python Bootcamp is co-presented by the GDG Cloud Edmonton and PyYYC. And we're really fortunate enough to have a lot of innovation leaders to help us to form this team of 7 local leaders in Python and data science. And we are looking forward to build active and engaging communities by having this course. And our main purpose is not only like, like a university lecture that we, you just go to the class and listen to the prof about the course lecture content. We really wish that we can stay connected beyond the class. Not only the class leaders and coordinators are facilitating this course, but you as a participant also helping to facilitate this course and also build a more welcoming and engaging developers community in Alberta. So for example, we have our Slack channel that here we're gonna, if you have questions about class, you can post, and anything, you don't know about coding, we have our course leaders and you follow classmates to be there to help you. And in this course, we have also 4 course coordinators will be in the Slack channel to answer your questions. So we did a pre-class survey before the class. So we think it's good for us to share a little bit about who are you to are attending these courses. So the first question is, okay, so a little background, we have we have about 100 participants, and we received, for the past 2 days, we received 35 responses. And in these 35 responses, the first question is, what are the factors that motivated you to sign up for this course? And over 60% of you said, I want to improve Python programming. And 25% said, I'm interested in the mentorship from experienced Python developers and data scientists. And about 8% say want to learn Python industrial use cases. And about 1% said, I want to teach my kids. That's cool. For the next is, does your work or study require coding on a daily basis? And we can see about half of the participants will require their work or study require coding on a daily basis, which is very good. And among the 35 responses, the next question is, what is your expertise level in Python from 0, no experience, to 5 expert? So there are about 12 of them, which is about 1/3, said, well, I don't have experience in using Python. And about slightly 30% of them have Python experience from 1 to 4. And 1% is really experienced in Python. But we also ask, are you familiar with other programming language besides Python? And the answer is actually 80% of the participants know other language besides Python, which means for this course, a lot of people have the basic programming experience and trying to or wanted to brush up their Python experience or to learn Python as their additional programming languages. Another question is, how do you reach your knowledge in Git and GitHub from 0, no experience, to 5 expert? So as we can see, there are about 1/3 of the participants have a pretty good GitHub experience from 1 to 3. I think I have one more slide for that. Okay, cool. So that's the pre-class survey, just to get to understanding of our participants and your fellow classmates. So the question is, Next is who are we and why why we're organizing this Python Bootcamp. So I'm Shinli, and I'm one of the co-founders of Google Developers Group Cloud Edmonton. So we are an official chapter of Google's worldwide network of cloud experts, developers, data scientists, and cloud engineers. And why we're organizing this course is our group has about 600 members, and we have volunteer that over 30 volunteers to help us to organize our events, including our machine learning bootcamp, our Python bootcamp. Like I'm one of the volunteers to help facilitate them. And we organized over 20 events for the past years, and we're only 1.5 years old. So what we really want to is we want to help our members to grow by advancing their technical skills and also networks and also career development. And running those course and the bootcamp is one of our core events to achieve those goals. And we don't want to have the lectures to have the course and you just come here to attend the course. We want you to be part of it and be part of the community and help us to build the Alberta's developers community. So next, I'm gonna hand over to Carson, who is the the founder of the PyYYC in Calgary.
Hey, welcome all to the Python Bootcamp. So I'm Carson, and actually the organizer leader for the Calgary Python meetup, PyYYC. We have 1,300 plus members, and people find it very useful for learning and finding new opportunities. We're collaborating with many groups, as for example, we're collaborating with GDG Cloud Edmonton, and we also collaborate with a lot of other meetup or event groups, both in Edmonton and Calgary, and actually among Canada. So thanks to this virtual event, we can make better connections and collaborations. So if you're willing to learn about Python, feel free to join. Our mission is to learn and share with what we know and help each other grow. So here we go. Go to the next slide, please. All right, so this course is structured in such a way that you can learn both the Python and gain some knowledge into some industrial usage. So for the first 2 weeks, you will learn how Python works. And by the end of the first 2 weeks, you should be able to write some complicated Python program to achieve some complex function. The third week will be web development with the most popular frameworks and the latest technologies such as async. The last week will be machine learning. So it will cover both supervised and unsupervised machine learnings. I've gathered a crew of the industrial experts with industrial leaders. So we have like team leads, senior developers, also other meetup organizers. So hopefully you will gain a lot from this course. Yeah, so let's get started. I'm gonna hand it over to Peter, who is a full stack developer at Showpass. He has been teaching Python for a few years, and he's pretty good at it. All right, Peter.
I just need the share screen to be enabled for me.
I just stopped the sharing, and Peter, you can start sharing the screen.
Okay.
And I forgot to mention while Peter sharing his screen is we will, for this class, we will have 2 sections. Each section is 1 hour and a half. Then we will take a break in between for 10 minutes. Our class is about 1 hour long, and we would really appreciate you type your questions in the chat box when Peter is giving his lecture. And after his first section, he will go to the chat box and answer the questions. Okay, cool. It's all gonna hand over to you, Peter.
All right, thank you. Thank you,
sorry,
Shinli.
Peter.
Oh, sorry. That was all right.
I just suddenly forgot one thing to say. So we will have 2 PyCharm license draw from the participants after this session. So for those who don't know, PyCharm is IDE that you can write code for Python. It's pretty powerful and it has a free version, but this license will draw a 1 year for the pro version for PyCharm. So the winner will be announced after the session and probably will be announced through email, I guess. Yep, that's about it. Go ahead, Peter.
All right. Hey, everybody. I'm Peter. I'm a full stack developer show pass, and I do this lecture here every once in a while for other organizations, mainly Momentum.org, and it's mainly for people who have tried to change their path in their careers and try to learn something different. So what you have here is that what we have here is like a really general sense of how Python works, or also like how to program it in a very elementary way. And the next few weeks we'll build out on that knowledge so that you can hopefully work on your own application. So yeah, why Python? And it really depends on what you want to do. Because like there's a lot of different tools out there, and Python is just one of those tools. And amazingly, Python is good at a lot of things. A few things they're good for: data science, machine learning. As you can see, we have a lecture on that. Web development, I know for sure because I use Python for web development, and script automation as well, because I used to be a QA person, so I use a lot of Python and a lot of Selenium to kind of automate little tasks. What Python is not good for is app development. There's no real good application or like frameworks for Python to make apps, unfortunately, and that's what really Kotlin and Swift is for. And for OS development, and it's only really because Python is interpreted. Like most Python, most of the time Python is developed with an interpreter, and interpreter, what it does is that it's another program that takes your program. So like kind of here, I can actually show you like a tiny picture of what I mean. Is that when you run a program in like operating system, you just have like this program right here, and you send it to like the command, say OS run this please. But for Python, what you really do is that OS run this interpreter, OS run this, then you have another like file that you input into the interpreter, then you run it. So you always have to have this little thing there. But that's just like one of the things that Python is actually like it's actually gives it a lot of different strengths and weaknesses because of it. And one of the strengths it has, because it's interpreted, is that let's say you want to run your program, you don't really have to compile. And if I don't know, some of you guys are like very versed in computer science, like there's a step from writing code right here, and there's like this little thing called the compiler that churns out machine code, like X, like bytes already, right? And this is what the OS can write. But yeah, like for Python, really the only thing you have to do is you have the code. Instead of compiler, you have the interpreter. And the interpreter already runs the code at that point. So it's very easy to kind of test out your experiments. Let's say you want to do like, you have some application, you want to go fast at it. You don't have to worry about waiting maybe like 10 minutes or whatnot to compile. Actually, that's a really extreme case that I know for sure. When a long time ago, I tried to compile my own Firefox, and that took 4 hours just to make it run. It's very painful. So we're very lucky that like tools like Python or even just Ruby and other things exist, because they let us go as fast as we can, almost as fast as thinking. But that's kind of how it is. But yeah, that's really like why we should do Python. And so for the next part in here, I said Python versus X. And I just want to compare it to different other tool set that we have. Let's say for C example, Python versus C. It's really like it's actually quite hard to define, as I said before, because like they're different tools. It's kind of like comparing a hammer to a saw. They're used for two different things. So it's actually like, as much as like you see a lot of in the different places on the internet that you say use this for this, it's just like they compare like different languages to get their performance and whatnot. Yeah, that's definitely comparable in that case. But you have to think about it as different tools. Python has lots of libraries on data sciences, on web development, and on data processing automation. You use Python for those. If you want to make a game or an operating system, don't use Python, or maybe use Python as a top level, but everything else uses, because as I said before, Python is good for automation. So use C or C++ for making your graphics engine. And yeah, just think about it that way. Like the different tools, there are different tool sets, and you'll just be upset at like figure out what you want to choose. What you want to choose. You want to choose. You want to see the problem, figure out what the problem means, then choose the right tool for it. So all right, installing Python. I believe you guys already had the five-page little primer to start Python off. For today, I said in the Slack, we'd like to use the collaboratory notebook. So the website is, I'll type it out right here. It's, yeah, I'll type it right here. Hopefully you can see it. So it's collab.research.google.com. Just go to that webpage. So I'll do that right now, right here. And I'll just wait like a few seconds so people can type it out. collab.research.google.com. So if you have hopefully you have your Google accounts ready already. Google takes, I don't know, a few seconds to get going, like to get your own account. Excuse me. And I'll press enter on here. And this should be the screen that you'll see right here, although this mine's kind of exaggerated. What you really need to do right now is just click this one here, new notebook. Let's go new notebook, and it'll open up a new page for you. It takes a little while for some people. Mine, I got lucky because I already was running. I'll just change the name up here. And we're actually good to go. We can experiment as much as we want. It's awesome. I'll just do a quick run through with the application itself. You see right here, this is a code block. A code block is where you put code. So yeah, so you can put whatever you want in here, X, Y, Z, whatever. But this will be run as code. And to run code, you see this run right here, this play button right here to the left side. Just press that one, and it will take a little bit of time to start up. Because what's happening is that Google's assigning you a new machine. So right here is an error because like I'm just playing around with it. But yeah, so now you have a new machine running in the background just for you. It's not using a new computer. It's not using a computer resources. So like you can have the heaviest program you have in here. It's gonna be okay. Then if you want to put notes and it's you want it to be formatted notes, this one is Markdown. So we can go GDG Bootcamp. And now right here, it's Markdown. So yeah, it's great because like let's say you want to preface this this code block right here. So what you want to do is move this up with this button right here. See this button right here? It kind of moves it up between cells. So I'm going to put it up on top. So now I have GDG Bootcamp. And yeah, so like you can actually have like a quick little thing to put in here just to say, this is what I'm working on today. And yeah. So yeah, yeah, we're going to start right now with the first thing that we usually do in a tutorial, which is a hello world. I just want to double check if anyone is stuck. No one's stuck, right? Oh yeah, thank you for putting that in there. I'll answer these questions during the break, just letting you know. Just put it all in there. I'll come back to it. So yeah, if you have a question right now, unless it's super urgent, someone would get. Let's see. That's a good suggestion, but I'm not actually using my mouse too much. I'm not so sure how to highlight it. Let me see. I'm on the web app, unfortunately, so it's going to be a little bit hard to do that. I'm sorry about that. Like I'm not a Zoom person, but okay. Let's move on, unfortunately. But yeah, as you say, how to get the collab. Just go up a little bit. You see in the chat. Go in the chat. There's one from GDG Edmonton. HTTPS collab.research.google.com. Just open that up in your browser. So we'll just wait for like a few more seconds. And I just want to reiterate, if you're lost right now, this entire lecture will be available to you later. I'll give my own copy, so that you don't have to worry about copying notes. If you just want to listen and just take it all in, that's absolutely fine. You can have your own. If you're a type that needs to write notes, this is like the next level notebook. Just let you know, is a great piece of software. But yeah. So we'll get started with the hello world, and the hello world is quite simple. You just go type print, then put hello world. So this is our hello program, and I'll press play. And as you can see, just types hello world. And just to, some basic parts of this hello world. Print itself is a function. And you can actually check out its function, and it's built in. So yeah, it's like just part of it. And this part, hello world, we define as a string, and we call it inside these brackets. And I don't know, some of you guys are already kind of noticed what it means already. But don't worry at the moment, we're just naming it. I'm gonna explain these parts a little bit better. So what I can do right now is that I can actually write some notes right here. So print, this is a function, hello world is a string. Then I used hello world as an argument, as arg to print. So right now it doesn't make sense. Maybe some people, but some people it makes total sense. That's absolutely fine. So I'll make a new code piece in here, and we'll just get going to like some basic stuff, right? So in Python, we're gonna be able to move around things, kind of like assign them to different names. And the way we do it is really called variable assignment. And I just want to let you one thing about Python is that I just go here, an object. I want to put an object into something. Let's say hello world, right? Just for the people out there who are kind of a little bit more keen, Python's gimmick is that everything's an object. And what it means is that when you assign something to Python, as you saw, we put an object, right? Object equals hello world. What we're actually doing is that in the universe where Python lives in, where it's working in, the interpreter or whatever, Python's making this object right here called hello world. All right. And it has a naming, like it has a list of names here. So it has, I have a name, an object, and I'm kind of pointed in there. So whenever you assign a name to a variable, that's really what you're doing in Python. You're kind of assigning it, like you're making something in its universe, and you're giving it a name right there. So later on, you can actually access like wherever you are in the, like wherever you are in the current place you are in Python, you can get it to say, oh, the object that I'm looking for is that hello world, what I've defined before. So just keep that in mind. And that's really like the basic way we kind of like, give names to things. And for the naming, I just want to let you know that certain words are reserved, and you'll note it more later. It gives a very specific error. So like I'll go here, if equals if word. And if I actually play this, it'll say if world invalid syntax, because if right here is this very specific term. And there's a lot of there's not a lot of these, but if you see this weird thing right here, you'll know that it's a keyword. It also highlights it a very different way. There's also like other things like for, and, or. There's just a few of them, but just be aware of those. But also like just to give you like so like the liberally how you can name things. Just a second here. Okay. Is that you can go you can pretty much like alphanumeric, although the first thing has to be always alpha, and you can put an underscore. Oh, sorry guys. Underscore and a 1-2 combo. 1-2 combo. Punch jab, the kind of deal. But yeah, so this is really like the only rule that you have when you want to name your variables, is that underscore alphanumeric first letter has to be a letter, not a number. What you come later is that like Carson, or like in the next session, there's other additional naming schemes, but this is really like the basic one. Okay, let's go back if there's any comments for me. You make your own collab file. But I'll just answer this very quickly. Make your own collab file, please, because like if you want to follow through, it's good for you to follow through. Like that's really like what I what I've realized help a lot of people or some people. If you just want to listen in, I said before, you can listen in. I'll give my notebook out to people. I clean it up and whatnot. Okay. Unfortunately, I can't help you out. I'm kind of tight schedule, but network occurred requests. It's a very complicated error. My suggestion is to like hard refresh, Control Shift R, or F5. Then make a new notebook again. Then press play. It should, because like this is kind of like in the system already, unfortunately. And unfortunately, I can't kind of like help you guys out individually to solve these problems. So, okay, I'm just gonna continue on. Before we move on to the next part, I just want to kind of talk about like one person said the comments and whatnot. There's a few ways to do comments. One way is to do this, a comment, and comments will not get executed in your code. So there's a comment right here. So if you go print hello world in here, this won't run because it's commented. Then there's also the triple string, triple quote, and the triple quote runs multi-line, so it'll only terminate when when you've done the next triple quote. So these won't run anything. Oh, actually, well, that's a string. Sorry, like that's well. Okay, I got two events in there, but this is actually a string, but it's for functions. Okay. I got distracted by one comment there, but this is like the comment. I'll talk about that later. Sorry about that, guys. Because this is kind of like out of my course outline, unfortunately. But yeah, I just want to make sure this is a comment. If you see me do it before when I did a slash like this or a hash like this, it's actually a comment. So it doesn't get run. Only if it's not there where it gets run. Right here. Okay. So I'll make a new one right now, and we'll talk about so types and type conversion. So the funny thing is that I have, like we're right here. So we're right here, basic types, you see, guys. I just want to reference that before we go. Okay. So I'm gonna make it bigger. You guys can see, right? Let me double check. My browser is Firefox. It's kind of like being in Twitch. I gotta answer every question every once in a while. Okay, so there's a few types. There's a few basic types that we really care about. So there's the numeric types. Numeric types are integers, floats, and complex numbers. Amazingly complex numbers. There's strings, strings and characters. These are basically like alphanumerics and special characters, like A, B, alphanumeric, alpha, and actually numeric as well. But they're not translated as numbers. And also like special characters like question mark, slash, comma, and whatnot. Those can exist in as a string. And there's a bool. A bool is true or false. This is very useful later when we do I'll just put it here, alphanumeric. What we do later when we use expressions. And there's a very specific one called none, which means none or null. Kind of hard to kind of describe it, but yeah, when something means nothing, there's a very specific one in there, none. But yeah, and the good thing about these is that like what you expect in this is that like numbers work with each other very nicely. So let's say you have 1 here, which is obviously an integer. You can add a float, which is usually like something with a dot. Float meaning a floating point. So the point being this decimal point. When it's represented a different way. You can ask me later about that one. But yeah, that's a floating point, and this actually works properly. Like it'll be 2.25. It won't complain, which is nice. So in other cases, we'll go print here so that we can see everything that we want to do. you know, there's like yeah, 1.5, you know, minus 1.25 will be 0 and whatnot. So it converts back to, you know, it doesn't convert back to it converts back to just a float. So just keep that in mind. And, you know, like as I said before, there's different types, and for numbers, they're very compatible with each other, but there's certain things don't go together, like those strings and integers. So if we add, like, I'll define a string, by the way, to define a string. Actually, I'll make a new code text in there. These are strings now. So to define a string, I'll tell you what, is kind of like this string, or triple quotes will be what I kind of move way too fast. It respects the spaces and the white spaces. So this is a string, and we can assign it to a variable string. And if we print this out, this will actually respect the new lines. If you do this new lines, if you do the new lines on a normal way of doing a string, which is the quotes, it'll cry because it didn't know what it doesn't know what it means. It doesn't know the new line. And just as an aside, you can define strings with a double quote. So another string or a single quote. It doesn't matter. My only comment to you is that you need to be consistent. And there's going to be a lot of different ways to format this. But yeah, just consistency is the key. So let's just check how people are doing. What types are dates? Dates are compound types. They're actually they define the date as a class. Well, we get that later. Like I'm not over it, unfortunately, but it's definitely a custom. It's a custom type. And from now on, I'll answer those questions after. I want to go through this so that we can kind of like have this nice, hopefully flowing lecture right here. So now, as I said before, there's certain things you have to be wary about. There are different types. You know, numerics can work with each other, but strings cannot work with each other. Strings cannot work with numerics. So this obviously will fail because, like, how can you add a string to a 1, right? I'll just say type error, right? But this is a lot more nefarious right here. 12 plus 1. You think that, you know, like maybe you're, you know, like maybe you're naive, maybe you think it'll work. It's a number right here. That's definitely a number. Add 1 to it. It'll still be type error because it'll understand it as a string. And what you can do is that, amazingly, there's a lot of ways to kind of go around this, is that you can make sure that they're the same type. So there's a bunch of functions that we can use. There's the int function. Let's make a text here. So there's the int function, which actually I'll have to get to. Like, there's a lot of ways to convert it. So there's an int, like, and the function is like something you insert into. I don't know what I'm talking about right now, but there's an int right here that you can use. There's a float that you can use. There's a string that you can use to kind of like make them compatible with each other. And then how to use these functions, as I call them, is that you put the argument in here. So input string right here. So input float, input string, and this one input whatever you want, number. What you'll find later, like when you study a little bit more, try it out, you can see that they're not actually limited to these types of inputs, but we'll just use them for now. So to solve this error we have right here, that, you know, like the type error, what you can do is that we want to convert that 12 into an integer. So now this one is like 12 int 12 right here. Then we're going to do is int 12 plus 1. And, you know, we've used like the variable assignment right here, a little bit a few compound things and whatnot. But yeah, we've assigned the return of this int into 12, and we used int 12 plus 1, and this should run and should say 13 because we changed the type. We've changed the type. And yeah, so like there's a lot of ways to kind of use this. let me just trash this one. Like you can actually use a string, because like what happens is that if you add 12 and you just want to go like what's this, if you just want to add like a you know, how old, you know, like, say it's like what time is it now, hour, and you just want to go like answer it being you want it to be, you know, you want to tell, they can combine it together to say like it's like 13, like you know, 1 o'clock. It doesn't work because it's type error. So what we can do is that we can actually assign this to a string. So 1 equals string 1, and we just go add this together and play it. Then it kind of like combines it together. So that's why I went a little bit forward in here in that like the string, you could add them together, but we can talk about it right after in a few I call this in a few minutes here. Okay, where are we right now? So we're at the basic types. We finished that. So we have the basic types. Actually, I still have to talk about some few types. So there's still like the trues right here, which is like a very specific thing. This mean like a you know, like logical true. You know, if you have an expression, which we'll go back in a bit, an expression that'll write to true or false, then you can compare true or falses with like, you know, or you know, and, you know, like the usual things that you think that you can use with logic, and it's going to be false and whatnot, or you know, like that kind of deal. Or we can go or in here and you can just play it, returns true. So that one, and then lastly, the none one is very specific. This none here is unique. Like if you want to mean something that doesn't exist, you know, it's very specific. Like it doesn't even return anything. So you play it, nothing happens because it's nothing. Amazing. And you know, if you want to check these like compatibility for sure between types, you can just call the type function. So there's a type here, and you put like the number 1. You put in there. It's an integer, it says right here. Although they're kind of short term in it. So a string right here is going to tell you str. It's a string. And yeah, so there's a lot of little things right here that you can then, I'll leave it up to you to like try it out and whatnot. This, you know, like you could just do this to everything. So you can even go none, and amazingly none has a type, which is a none type. This actually goes back to the idea before I told you everything's an object. So everything has a type because it's an object. It comes from something. It comes from like that meta, you know, the meta thing that it comes from. Everyone has those. So now let's see where we are. So we're going numbers and arithmetic. I'm just gonna go with like what basic functionality we have. Actually, before we go, I'll just see if people are lost. Yeah, thank you. That's very nice. Yeah, and as I said before, you just want to listen. I talk relatively fast, so I'm sorry about that. That's just me being, you know, a little bit excited and nervous, and you know, kind of just like enthusiastic. I talk very fast. If you can't follow, I'm gonna try to slow down as much as I can. And I just want to reiterate, these notes are available to you. My own notes, not necessarily this one. A clean version of this will come to you, as well as this. If you want the raw version, I'll give it to you for sure. So now we're on the numeric types. There's a lot of things that you can do with numbers in Python. Amazingly, you know, there's plus, there's minus. Yeah, there's a plus, addition. Okay, I'm gonna do this because the other ones, there's you know, minus, multiplication. Hopefully that one doesn't cry. You know, division. So there's 2 types of division: normal division and integer division. I'll show you the difference in a second here. There's also exponent. This one right here, and also like some nice functions to go like absolute value, maximum between 2 numbers, so max, or like a few things, max and min. There's a lot of nice things that you can use right away. You don't have to implement them. And the good thing about numbers in Python as well is that they are compatible with each other. Like you can't say that for C or C++, you have to convert integers to doubles if you want to, you know, work with them. or you just have to have everything doubles, and you don't have like the nice integer kind of functionality. So yeah, we're just gonna, like it's very basic. So you go 12 plus 1, there's that, and we go 12 divided by 1, which is 2 at least, so it's not a trivial answer. And there's actually something very interesting here. As you can see, I divided 12 to 2. And if you know like how the domain works for these, is that if add and subtract things together, the domain is integers, but the range of the values that comes out is still integers. So when we do add together, it's going to be an integer at the end. But like for the operation, a division of operation, the closure of the division of operation is actually not integer. To close that operation, you have to include the rational numbers. So right here, it's just like implicitly just gave us a rational number, which is 6.0. Although this is still integer, but let's say we had to go with something like 13, which will have some fractional part for sure. So it'll be nicely fractional. And as I said, this is a good thing about Python. That it's very easy to work with types, like numeric types, because most numeric types can work with each other, and especially the basic ones. And to kind of like add to this division, as I told you before, there's another kind of division, which is the integer division. This one will round it out to the next integer, so it'll be 6. For certain operations, this is nice. We'll use this later. We're like, what to use this for? We'll use it later. I found a way to use this. So that is always like, if someone made it, someone always figures out how to use it. So which is great. But yeah, so just to kind of like add a little bit more, the functionality in here. As I said before, there's absolute value. So we can go minus 25 here. It'll be 25. And yeah, as you can see right here, I just put minus at the front, and it recognizes the minus number, which is quite nice. I believe you can do this. It'll be a -1. So some languages don't support that. So yeah, we're lucky. We're kind of spoiled in a lot of the functionality in here. And yeah. So like we'll add one more here. The max and the min, they're very similar to each other. So max, as you can see right here, you type it out. It says right here what you want to do. So like that's 12 and 6. What's the max of this? Is going to be 12. Yeah. So that's it for numbers. Take a tiny 2-second break. Okay, nothing in there. That's good. Everybody's good, hopefully. And for the next part, we're going to talk about strings. And yeah, so what are strings? Well, what we're really talking about here are strings and characters. So a character is pretty much anything that, like you can kind of store as like a certain value. But sometimes they have like, they have some graphical meaning, like the number C, the byte something translated to the letter C, or like the byte X something translated to like the number 1, that kind of deal. So it's really like some mapping, and this is kind of like a general purpose kind of like a value, right? But like if we combine them together, that's really what a string is. So a string is like a group of characters. And yeah, so strings are unique in that it's actually like a very basic data structure. And because it's a data structure, Python kind of gives us a lot of different functionality to access what's in there, right? So let's do like a very basic A, B, C, D, E, F, G. Okay, so I have a string named A, B, C, D, E, F, G, or a string with the value A, B, C, D, E, F, G. And as I said before, it's a data structure. So we can actually access every part of this string. So let's say we want to access the first part of the string. How do you do that? We just go use the bracket notation. And bracket notation, we put an index in there. The most basic case is what we put an index in that square bracket. So you put 0 in here, and just to iterate, like indexing in Python starts at 0. So the 0th part of the string is going to be right here. As you can see, it's A. It's A right here. So I'll play this. Oh yeah, sorry. They didn't define it. Okay, I'll get to these errors later. But yeah, so the 0th one is A, and the last one is 0, 1, 2, 3, 4, 5, 6. So the sixth one is going to be G. So that's basically how you'd access, like a very specific part of the string. And now, the good thing about this square bracket notation is that you can actually, amazingly, take sections, which is, that's nice. And we call this slicing. So we want to slice this string out. We want to take the first 3 right here. So what we want to do is that starting from the 0th one, the A one, 0, we're gonna take we're gonna go up to the 3rd, and we're gonna include that. So we're gonna go up to the 4th, but not including it. So what we're really trying to do is that the next number right here is that I'm gonna go up to the index, but not including that index. So I want to take ABC out. So I have to count up to D. So 0, 1, 2, 3, and I know that part's not going to be included. So I'm going to play that, and it's going to be A, B, C. So just to kind of reiterate here, the first part right here. So the string, we're going to call it M and N. M being the start index, and if people have the index, I've been using it already very liberally, but an index is pretty much the number assigned to it, depending on where it is in like an ordinal term, like an ordinal value. So in terms of the ordering, I'm going to assign each of these a value to order it with. And the first one here always have this 0 as its ordinal term, the ordinal value, so the index would be 0. If I'm kind of getting complicated how I'm explaining that, but yeah, so this is going to be 0, this is going to be 1, this is going to be 2, 3, 4, 5, 6, indefinitely for how long as how the string, as long as how this, how long the string goes. Then okay, so go back to it. N would be it's very specific here. You have to always be careful of this one. It means that go up to nth index, but not including the value at n. So as I said before, in our case right here, we start at 0. So 0 here, 0, 1, and go to the 3rd index, but don't include it. 0, 1, 2, the 3rd, don't include it. So ABC. So just to kind of like add another example right here, we're just gonna go a string. We're gonna start 1 and we'll end at 5. So it should be from 1, 2, 3, 4, 5. So it should be like B, C, D, E. I'll play it right here. And yeah, B, C, D, E. So this is called slicing. And there's actually additional ones that you can do with slicing. You can actually tell it how many steps it'll take forward. So I'll do that right now. A string. So 1 to 5. But we only want to take every other one. So let's go with 2, actually. Take 2 steps. So what we do is okay, start 1, B, I'm gonna do 2 steps, 1, 2, D, 2 steps, 1, 2, but actually it won't be there anymore because that's over 5. This is actually 0, 1, 2, 3, 4, 5. So it won't include it. So it's gonna be B and D if we run this code right here, this path right here. And that's BD. So I'm gonna add the last part in here in that, and there's an S right here. S being the size of the step from M to the next value to take would be slice the string itself. Okay, let's go. Yeah, thank you. Okay, thank you for people who are explaining. Thank you, Daniel, for explaining to everybody, keeping my flow going. Very, very nice. But yeah, so that's the basic way of using the string. There's actually a lot of different functions around the string, and actually very specifically, it's not a function, it's actually a method. And I'll just touch on what a method is very, very briefly right here. I was just going to go back when we said in the variables that everything in Python is an object. And if you're very familiar with object-oriented programming, objects would have attributes, which are kind of like attributes, I guess, that inherit to itself, right? So let's say you're a dog object. A dog would have 4 legs. So you have legs equals 4 as your attribute. If you're a person, like a human, you'd have 2 legs because those are the ones are hands. So you, like, your legs are equals 2. So that's really an attribute. A lot of these are going to be talked about by Carson in the next Carson and whoever it is. Sorry, I forgot. For the next part, which is kind of covered by classes. But I just want to give it a little bit of background here because, as I said before, everything's an object. And because they're objects, they have attributes and they have methods. And methods are functions, like things that you can, like routines and like instructions that you can use with the very specific context of that object taken into account. So in our case, let's copy this string here. A string right here, go down here, next part of code, a string, right? There's a lot of things we can do with this. So a string, and I told you before, to do a method call, we have to put dot. And as you can see, it already gave me a lot of different things. We can use, this is a lot of different things we can play with, but I'll tell you a few of them for now. Upper, what it does is that take this string, turn everything into uppercase. So I'll play that. Everything's uppercase, which is awesome. But the thing is, like, so let's uppercase. Let's assign it to something. Uppercase string, because we want to make it lowercase. So we go down here. Dot lower, and I'll just return back to the being A B C D E F G. Yeah, there's a lot of these. There's a lot of these functions, and you can see right here. And as you can see, they're very straightforward in how they name it. Capitalize means that make the first letter capital. Case fold. Actually, I don't even know that one. We can try it out. ABCD. I don't know what it does, but okay, there you go. That's not part of the lecture, unfortunately. But there's a lot of these. There's a count right here. Actually, I'll talk about count because actually that's one of the things I'm talking about. Counting being that you insert something in here like a substring. So let's say ABCD, and we're going to count how many instances of that is in there. So I play it. There's going to be 1. So let's give it something different. So let's put something ABCD. So there's going to be 2. Oh wait, amazingly, there's 2. So there's a lot of these. As I said before, some really interesting ones. We can actually even go find. So what can go find is that let's say we want to find this string pattern right here, and as it's string, but you can actually just put like 1 because 1 is also a string. But just 1 value is also a string. But yeah, so we'll play this right here, and there's going to be, and when it says number, it's 3. What it actually means is that, I'm going to put right here, is that returns the first index of the occurrence of the input, right? So I put in there def. Where does def exist in here? And this the find told me is at 3. So let's go 0, 1, 2, 3. Okay, so that's that makes sense. All right, it makes sense. So yeah, string is one of those. There's also another one that does the same thing, but it returns an error to you if you don't have it. So how about this? These 2 are the same, so I can actually comment this out, you guys. Actually, if you haven't realized yet, sorry, I'm just telling you this now, is that whenever you are in a code block right here, the last thing that you put in there is the output of this value right here. Just letting you guys know. I forgot to tell you in the really rough guide of the notebook, but the last thing it says right here, this is the one that pumps out from here, unless you do a print statement. Unless you do a print. So like if you print a print right here, ABC, it'll do like 2 things right here. But if you don't have the print, it'll just run the last one right here. Okay, so just let's decide. But the index right here does the same thing as find, except that they handle errors differently. So go right here. If you go right here in string find, and I want to look for fed, this just returns -1. And for straight find, if you read the documentation later, like how it works is that it'll tell you -1 if you didn't find it. The difference for this versus index is that if you put fed in here, it'll tell you it's an error. It's not found. So depending on how you want to use it, it might be very useful to you. So the last few things I'm going to talk about in like we call this the things that we can use with this is that there's two more things I want to talk about. Is that there's the replace. I want to talk about the replace, a string that replace, and it's very straightforward enough that like you want to go A B C, then you want to relate to like X Y Z. You can play that one, and it kind of just replaces every instance of A B C to X Y Z. Yeah. And finally, the last one, which is kind of maybe a very different way we'll do it, is that go here. I'm going to use the bracket notation again. Is if you use negative numbers. What happens with negative numbers? And what happens is that it goes from the back. It goes from this side right here. So 0, -1, -2, -3, -4, -5. And it works pretty much the same as how you would think it would. As long as you're ordering it properly. So -1 will be C. Then you can actually kind of cut it from there. Go from -1 to -3. So it's going to be -1, -2, -3, but not including the -3 right here. So it's going to be B and C. This is going to be, oh, that doesn't work. Oh, weird. But okay. Wait, it doesn't work. It should work. Wait, let me check my notes. Unprofessional moment. Yes, it doesn't work. Okay, it doesn't work. Okay. You have to, yeah, it doesn't work properly. Okay. Don't just forget about that part. But yeah, you can actually use this negative one right here. If someone can double check that for me, that'd be awesome. Yeah. You can use length for sure. So yeah, we're moving on to the next part, but you can definitely use length at the end. But actually, I forgot one thing. Very, very smart to use length. The length and the count are the same. Or sorry, the length, I forgot to tell you the length, which is not in here because I'm using it for a different part. I'll talk about length right now to get to the end. And I forgot one part of the slicing. So we'll go to the advanced slicing right here, is that you can actually go like this. Start from the first one, and you just go colon, and with nothing in it. If you go nothing in there, Python kind of understands it as go until the end. So start from 1, which is going to be B, and it just goes up to the end, B, C, D. I'll take this out so it's a little clearer. So it just goes till the end. And similarly, if you forget the start and you just go put it to like a number, what it means that we're going from the start right here and we're ending up to, but not including the fourth one. So 1, 2, 0, 1, 2, 3, 4. So just ABC right here, or BC, right? 0, 1, 2, 3, 4. Sorry, A B C D, because this is the fourth one. Okay, so yeah, you don't have to use the length in there, but yeah. So it starts from 0 at the front exactly, but it starts at -1 if it's -1. I would just think about it like, kind of like the anchor is always the first one which is 0. Then you kind of go back. If you're indexing with a negative number, you're kind of like going backwards. But because there's nothing to the left side of it, you kind of do it like a modulo where you go to the other side. You kind of go like this. So let me just illustrate it in like in a different way right here. So we have this data structure of the string right here, A, B, C, D, 0, 1, 2, 3, right? So when we index forward, right? So we add 1 to the index, we're kind of going this way, right? So with a positive number, right? But if we're going with a negative number, we're indexing backwards, we're kind of going this way. But because there's like there's nothing there, Python kind of decided like we're gonna go, sorry, we're gonna go here, then we're going to go backward this way. So the direction of the negative is that way. So negative goes that way, positive goes this way. So if you, yeah, so just kind of like think about it that way. So the anchor is always the same. Like the anchor is always 0. Yeah, exactly. Like a modulus. I don't know if, if super familiar with how the modulus, I use the modulus word, but yeah, that's like the modulus, a modular arithmetic. Okay, all right. Okay, double checking in here. Okay, we still have around 30 minutes until our first break, and we just have like a couple more or 3 more things to go through, so it's good. So let's do the next part. Next part right here in my list is basic input, and this is amazingly short. So basically, it's just this input and whatever prompt you want to do. So like, give me something. There. Then you want to kind of assign the value that coming out related to some variable. So like my var right here. Then you can use that variable whatever you want. Depending on what environment you are in, it actually acts as differently. And this nice thing about the Collab notebook is that it gives you this nice UI. Hello world. Then you press enter, then it kind of prints out, it goes to the next part. And as you can see right here, it actually waits out for you to give something. Right. So this is, so if you want to, like in this case, you want to input something in here, you just kind of wait it out from here. Waits out for you, then it continues after. And the important thing you have to note is that my var is always a string. Like if you don't do anything like this basic way right here, it's always a string. So let's say like if you use the my var +2 like this, play it. If you put 1 in there, it's like, oh, I can't add them together because they're different types. Like going back to there, it's different types. So the good thing probably is to convert this to some value. Use a type conversion as we talked about before, and just to make sure it works. So this always returns a string. If you want to clarify that a little bit, there. That's it for input. So now we're gonna go with the operators, Boolean operators. I talked before. There's like the Boolean types, comparison operators, conditionals. So we'll talk about Booleans first. Hopefully, a lot of you guys have been are what do you call this? Acquainted with the Boolean logic. We should be pretty much like manipulating true or false, and there's also like a few things that we kind of like use to compare each other, is like or and not. So these like operators, and they work exactly as how you would think it would work. If it was like you doing some mathematics and whatnot, like Boolean math. So you go have a true or false. Obviously, the or operation always return a true in this this kind of statement, so it's true. And you can do other things like this, like true and false, which is going to return to a false, because and in the truth table for the and is like that. And finally, if you negate something, you just go not false, which is going to turn into true. Okay, so what can we do with this? There's a lot of things we can do with. We can compare, and because as I said before, a lot of things kind of like evaluate to true or false. We can compare their truthiness and falseness, and we can do some kind of operation. So we'll try to get like truthiness, falseness, and certain things first. We'll use, and for that case, there's a thing called comparison operators, right? So there's a few things we can do. We can do equals equals with kind of like is an equality. Actually, I should make a text on this. Delete this one right here. Okay. Okay, there you go. Okay. Sorry about that, guys. So I'm just gonna list out whatever the comparison that we have is that we have equals, which is equality. I practiced that so many times. Less than equal to what's this? Less than First, the basics, you know, greater than equal to. I'm going to put it in here. Greater than equal to, greater than equal to, and not equal, which is, you know, not equal. Right here. And these things return bools, like these types. And as you can see right here, you can use these operations as well to kind of like get some kind of, you know, Boolean formula, right? So we'll have an example in here. Go down, please. So 1 equals 1. That's true. So 1 equals 2 is not true. Yeah. 1 equals 1 or 2 equals 1, and it's going to be a true because, you know, like you can combine it together, because this one returns a true, this one returns a true, this one returns a true. You can use the or to kind of combine them together, and it returns a true. And a concept right here, like if you realize there's a concept right here that kind of like we're using, and it's called an expression. And right here is that there's this one expression right here that returns a value, like a singular value, and there's another expression right here that returns another singular value. We can combine them together, and that's really how like we use these like statements together, so we can form like a very complicated like Boolean switch, right? And we can use that switch in like a different, you know, like a use case, like later on, like I say, if you have a loop, you're going around, and if the number that you're accumulating becomes this, you can exit out, right? So this is usually like this is how we're gonna do that. We're using these expressions right here, and we're using this operator right here. Let's see if I have any questions. What is true or false? Output true. True. Yeah. Sorry. I'm asking very quick questions there. True or false? Output's true. It's really because of this. I'll show you what it is. Because like there's in logic, there's the or operator, right? If you input the values of like, so let's say or A or B, right? So this is A, this is B. So 0, 0, 0. Sorry. Wait. Let's clear this up a little bit better. Okay. So we're trying to figure out what A or B means, right? So we go put A and B right here, and we're gonna go right here: false, 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 true, true, false, true, and true, right? So this is the output. So this is pretty much just Boolean logic. So like false or false, which is gonna be false. Yeah, false or true is gonna be true. True or false is gonna be true. So this is like the truth table. Like it's pretty much Boolean logic. That's why like the or works that way. It's kind of hard to explain a little bit more elementary than that because maybe yeah. But yeah, I could talk to you about ask me about Boolean logic a little bit more later. But that's just Boolean logic. It's saying true is true. Oh yeah, okay. Yeah. Thank you, Carson. Thank you, Elisa. Yeah. Okay. Cool. Translate the images. Sorry, I got I got distracted there. Okay. I gotta focus. We gotta focus on this, including myself. Sorry, everybody. I gotta focus on this, because usually when I do these courses, I give time to people can ask me like directly, and the chat is very very new. So sorry about that. I'll keep that in mind for future cases. So next up we have here is that, as I said before, these are expressions, right? And expressions amazingly can be assigned to variables. So let's say one expression we have is going to be 1 equals 1, right? Another expression, equals 2 equals 2 equals 1. Yeah, you have to be wary about these equals and equals. Equals is the assignment operator. This is the equality operator. Very, very careful. Yeah, very careful, guys. Then we can actually use this now to go or other expression. So just to keep that in mind, we can use expressions like that. And you know, like there's another thing that you can do is you can actually group expressions like this to kind of like tell Python like, I want this worked on, kind of like this, or 1 equals 3, that kind of deal. And we can actually, we could go that, and it kind of tells you operate on this one first, then operate at this one, and operate in this one. Then solve the thing. So yeah, this is true right here. Okay, options. Okay. So we have now expressions and Boolean logic and whatnot, and we can use this in a lot of ways. And like the most easiest way, like the most common way to use it is through if statements. Right? I said before, like it's just sticking an expression in here, and we can act on something, right? So let's say if 1 equals 1, which is pretty much like true, we'll do something. Print true. This is true. I agree. Okay. So print it, and it does that, right? And the thing is, if we make this into false, so this one evaluates to true when if the expression in this if part evaluates to true, it executes what's inside of the block. And actually, there's one very important thing that you've noticed here. Right? There's a block, the concept of a block. And what is a block? It's pretty much just like a piece of code that kind of like under a domain of like another construct, which is if right here. And the way we've actually the way we've separated out from everything else is that we put a tab right here. This tab right here tells us that this print is the code block. This print belongs to the domain of this if, right? This if has some code after it, and if it's true, we're gonna run that code. So now, so that's a block. So I'm just gonna write this down for you right here. Print is within a block under if. Run this block only if the expression in if for version to if, I guess, is true. So as I want to give you like the anatomy right here is this is the if statement, right? This is the expression that we're using as the input, and the part right here is the block. Just to kind of like solidify that, the anatomy of this construct right here. And if we play it, it goes true. So if we change the value of this to being false, so 1 is definitely not equals to 2, and that's false, it won't do anything, right? That's it. So now there's a lot of like the if construct has a lot of different like additional functionality to it, and there's two things that we can do. Like we could actually add an else statement in here. So what happens is that if this is false, we'll run the else statement. So print this is false, right? So you go in there and it prints this is false. And I just want to kind of reiterate in here. I'm gonna label this as print. I'm gonna kind of make this a little clearer. This print right here, print this is true, right here, and I'm gonna go in bottom right here, print this is false. This is within the else block, so it's under the domain else block, so it doesn't actually run if the else, like if this is false, or if this is true, it doesn't run. So we can just double check it with you. It doesn't run. And there's actually another thing in here that we can do called an elif, which means really like else. If this one right here on top of me is not true, check me again. But I have like a conditional statement. So let's go 1 equals let's say like 3 equals is greater than 2, which is definitely true. This is again true. And what happened here is that as soon as one of these blocks run, the entire thing doesn't run anymore. Like it won't run the else anymore, because this is the one it exits out. So we run in there and this is true. So if we add one more in here, like we add something in the bottom right here, another else if, which is going to be true, is once again. It's oh sorry, we're actually right here. Sorry, I kind of blended that one. So we're still right here. We're still right here because like it goes in here. The precedence is that it goes from top to bottom. So it goes, is this true? No. Is this true? Yes, exit. But if it's not true, let's go like this. Is this true? No. Is this true? No. Is this true? Yes. So it'll come out in here. And ultimately, the last one that it comes out to is going to be the else, like the ultimate one that, like, whatever happens, this will happen if everyone else fails. So that's how you kind of combine the if else's. Like, don't abuse this too much. A lot of people would complain about that at one point, but there's a lot of different ways to kind of abuse this kind of like else if. But that's it's just me talking about random stuff. But yeah, so if else right here. Nicely enough, Python has a lot of other things that it wants to do. Let's say you have this kind of construct right here. If 1 is greater, actually let's put it the variable. Like, so a number equals 5, right? If a number is greater than 3, then let's say another number equals 2. If not another number equals 1. Like, it's pretty much nonsensical, but like what we're trying to do is that, like, depending on what number we're using, we're gonna try to figure out what to do with, like, what to do with this assignment right here. So number is 5, so it becomes 2. But let's say this one is like 1, and it becomes 1, right? And we just put this like if else right here, and this one, like, let's say you forgot to do something right here, it just goes like this. Right here, you forgot the else, you play that 1. But let's say what if happens is that if it's 5 is greater than, right? Or actually, yeah, okay, play that first. Then okay, I gotta go because like it remembers the last context. So if another number is not described before, it'll play it. It'll wait to get another number. Oh wow. 1 second here. Yeah, 1 second, guys. 1 second, guys. This didn't run as expected. Weird. Okay. Wait 1 second here. 1 second, guys. I'm gonna trying to remember. It's obviously not bigger than another number. Okay, I'll just put another value in here, some value, because it's kind of like overlap. Okay, so what happened is that if you put some value behind like this if, it's this code block, it doesn't get run, right? And if you assign it later, it's gonna fail at one point because you didn't assign it. So a way to go around this is that we can do this. Actually, this is called a ternary operator. It's kind of like an aside now. So we assign a some value, and like we assign it like the one that like if number A. So we're gonna do is like 2. So 2 if a number is greater than 3. So it kind of encodes this information. But if not, so it always reminds you to put something in there. Let's put 1 in there. So in this case, it always prints out, right? Wait, I can put a number in here because it kind of takes the number from the top. Oh, geez. Okay. Sorry about that, guys. Equals 3. So play that in there. And we can change this into a value. And we go like 1 right here. Kind of, goes around. Yeah, it follows this kind of like syntax right here. Sorry about that, guys. I kind of got, what do you call this, tripped up with another one here. But yeah, so basically it just kind of like encloses this if else right here, if else. So this one here is pretty much equivalent to this, equivalent to a value equals none if a number greater than 3, a value equals 2, else a value equals 1. Okay, so yes, so that's really like their equivalent. And yeah, that's it for if statements and whatnot. So let's go in here. If you have any questions right here, we're gonna take a quick break right now. Come back at like 2:30, and we're gonna use all that we've learned right now to make something. So yeah, take a 10-minute break. If you have questions right now, answer it as much as I can. But yeah, 10 minutes, 2:30, guys, 2:30. or let's make it 233 or 232. So, oh geez. Can you show your screen back? Of course. Sorry about that. I'll put you guys at the side. Give me a second here. I realized that I can put you to the side and I can talk to you. There you go. Is this structure of a variable? I'm not sure what you mean by structure of variable, but what you've done right there is that you're the object. Yeah, you have an object variable. That's correct. Then the function is the technical term for the function is actually a method. The method belongs to that object variable that you have. And I'll draw it out right here. And Carson is exactly right there. It's a class. That's like, if you know what a class is, that's exactly what it is, right? That's exactly where you're getting it. But like, so you have this object variable right here. The object variable comes from some class, right? It's like the class is kind of like the template. Okay, well, the next session is very good for this, but I'll just make a very, very basic, super high level description of it. And like Carson will cover it. And we have like 10 minutes anyways. So if you don't mind, Carson, I'll just do like a very quick one. So what happened is that, yeah. So thanks. So there's this object you have right here, right? The object, let's say, that's obviously like a circle, and we have like a mold right here of a circle. Okay, actually, let's make it a little nicer. So we have a sphere right here, right? A sphere, and we have a mold of a sphere right here, right? Inside, and there's like a mold and like a thing right here, like in let's say we're casting it metal, right? So we have a mold right here, right? And the sphere right here is like what the thing we made. So in this analogy, the sphere, the product itself, is the object, and the cast right here is the class. Class right here is the cast. What I mean by that is that like the class kind of dictates what the object would look like. It's kind of like a template, and the class itself has the ways to kind of build that object, right? So when you see a class being defined, like the class will specify, oh, the object will have like in case of like an animal, let's say like class animal. The animal, oh man, bad handwriting right here, sorry friends. There's legs. Oh, animals have legs, animals have brains, and there's gonna be brains, and animals will have like digestive system. Yeah. So at least they can move around, they can think, and they can eat, right? Sorry guys, my headphones kind of fell off. So what happens is that like, oh, I'll make an animal. Okay, we'll take the class, pass it to the class, comes out with an animal. So it has a digestive tract right here. So it makes a digestive tract. There's some legs. Then there's some brains. So weird looking animal. We didn't define if there's eyes and whatnot, but so what happens is that like the class kind of dictates what the object will have. And in your case, the object variable, the class said we're gonna have the function, and the function is a very specific attribute. It's pretty much just a method. It's a method like that. It's not structured, but the object has it. It's something inherent to it. And whenever you call that function that's a method inherent to it, it always knows what you are. It always references what you are. So it always knows like, oh, I'm animal, I'm walk. Like say your function is to walk, right? Or your method, really, the proper term is a method. The method is to walk. Tell that animal to walk, like a person would walk differently from an animal with like 4 legs, right? So it's very inherent to itself. And that's really like the thing about object-oriented programming in Python and whatnot. Is like, you got to remember your context. The context is your object and your methods and whatnot. And yeah. Thanks, everybody. Yeah. And yeah, Carson will cover this next week. Yeah. So if you have any more questions, we have 8 minutes, or like 4 plus 2, 6 minutes. Data type. The data type itself is the class. Because what happens is that this is because whenever you do something like this to Python, like when you go, I actually want to zoom in a little bit more. Okay, when you go type some object, right? What's doing is that it's retrieving you the class. Like in most cases, it'll retrieve the class. So the class of the object. And that's how you use to construct that object. So the data type, the thing is like these are kind of like different concepts in general. Because data types kind of like work at a different abstraction layer. But yeah. Oh, thank you. You're welcome. Sorry. Thank you for the compliment, and you're welcome. Yeah. And I said before, if you are having trouble following, I will give you my copy of this. You'll have this. I have another one of this that's completely cleaned up with documentation. So I'll give you that as well, so that you can reference them. Sorry, I'm reading the comments there. Yeah, but sorry, what I'm trying to say is that you'll have this notes right here for you. So if you just want to sit down, relax, and listen, absolutely fine. I do suggest though, the next time when you go to Carson's class, and Carson Keegan, right? I can't remember who the other person is. I want to mention his name.
Keegan.
Yeah,
Keegan's gonna do it.
Yeah, Keegan. Yeah, Keegan. Please review them, because you know, like he might not have the same setup as me. We're all different instructors. We all work relatively independently of each other. So yeah, please review them, and you know, like these are accessible to you. So, and you can, you know, like once you get them, make a copy, then do whatever you want. Add more notes and experiment more. And you know, like the good thing about the collab notebook is that, you know, it's there. You don't have to set up. You can use your tablet amazingly to run this. You can use, you know, you could use your laptop, you could use your phone. The phone not very optimal because the screen's small, but the tablet works perfectly. You can use I think you could even use your PS4, PS5 if you have a PS5, lucky enough. Good on you. To study Python, so you can, like, let's say like you're trying to find an excuse to buy a PS5 to your, you know, like partner or parents, like, oh, you know, I could learn Python using my PS5. Then when they come and check you out, you open the web browser and go to like collab.google.com, you know, typing out Python functions in there, and they say, oh, that's awesome, you're doing good there. Yeah, thank you, Daniel. Thank you, Carson. Yeah, thank you, Golem. Sorry if I'm saying your names wrong. Yeah, this is, like, as I said before, they will cover this next class. Yeah, if I'm not explaining enough, yeah.
Seems like people are really interested in class and objective oriented. And
Yeah.
methods, those kind of things. So basically, we will cover that in the next week. People, please save your questions to the specific content that Peter was talking and is talking. So and save all the class-related questions to the next week.
All right, Daniel. Daniel. I'll try as hard as I can to say it properly. Daniel. Yeah, we have a few more minutes here.
Well, Peter, so I think we are about the time to do that 10 minutes break before we start the section 2. And great lecture. I think it's really good, you know, introduction and the fundamental for the Python.
Yeah. Thank you, everybody. Thank you.
So, yeah, we're gonna be back into 2:40, and if you have more questions for Peter or the class in general, feel free to post it in the chat box. And if Peter wants to keep talking and answering questions, feel free to do it.
I'm your and you know, like in this 10 minutes, I'm your entertainment. You know, I'm the streamer, so you know, there's no tips and whatnot, unfortunately. Just kidding, guys. I watch a lot of Twitch, so
nice. Yeah, I read all the times. Anyway, so people, I've posted a couple images in the Slack channel because I can't post them here. So those are the list indexes and the truth table. I will continue posting images for like, the course related materials to the Slack channel, so you can all take a look. I've also pinned them to the channel. Like if you're late or missing anything, you can always see the pinned items. Yeah, keep an eye in the section as well, and feel free to ask any questions in the Zoom chat here.
Yeah.
Alright.
That's a good idea. Is like, say next time I do this course again, I'll keep in mind to put the truth table, because I've kind of implicitly thought that people know the truth table, even though it's really not taught even in high school, if you think about it.
Yeah, truth table is only taught in the electrical engineering and computer science, I guess.
Yeah, it's true.
Yeah. And also that list index is really, really easy to understand. I found that when I was learning Python, this chart actually helps a lot. So
yeah. Thanks, Carson. Yeah, there's definitely any of these kind of material is good. Like, I'll keep this in mind for next time I make this. Have these pictures ready. Yeah.
Cool. Peter, if you want to take a break, I can play some music, so you can take a break and drink some water.
Yeah, I've been literally drinking this water here. Yeah, I'm just gonna sit here. Relax, do some. If
Daniel
you want
said
to,
he can just sing.
Oh, okay, that's actually I thought you were telling me to sing. Okay, that's good, because like
No, I
if you
said I just
don't-
can play some music, so you don't have to keep talking. You can take a break for a few minutes.
Yeah, for sure.
Well, Daniel, is your last chance. If you really want to sing, please go ahead. Otherwise, I'm gonna play music.
How can we check for truthy values here in Python?
Say it again, please.
To see if a variable is not null or a variable exists.
Oh yeah. Where is this? There you go. Yeah. You can. There's, I told you before. A few cells back, there's the very specific none type right here. You could actually go, if you do that, if none, if x equals is none. Actually, the very specific thing is none. Then you do something. Do something right here. To check if a variable is defined. You know what? I never actually thought about that. Usually what you do is that, like, let's say like x plus 1, or let's say something undefined, right? Undefined. The thing you have to do is that this actually would do an error, and you catch the error. This one I'll discuss later. So I think this is probably what you're asking, if that something is defined, right? If a name is used. And what we can do later is that, well, actually, I'm gonna cover this later. Like, this is an error about it. So, we're not kind of lost in that in that part. Does that answer your question?
Yeah, thanks.
Okay.
we'll cover try except next week.
Yeah, I'm gonna cover try except in the next. Let's see how far we are.
Yeah. So we can use try except to catch undefined.
Yeah, right here.
But we rarely do that. So
yeah, so it's actually at the end right here, unfortunately, but not near the end. But I'm gonna cover that part. The next few parts are relatively quick, because like a lot of it has already been covered. But yeah. Excuse me.
Okay, how Peter is ready, and it's time for the second section. And great, it's all yours.
Okay. Hello, everybody. So for the first thing that we'll try to we'll try to kind of put everything together, at least the current things that we know, to something maybe just even tiny bit useful. So what I'm thinking right now is that so sometimes when you watch news and you kind of watch American news, and they always tell the weather as Fahrenheit. And we live in the Celsius world, like pretty much every civilized society. But yeah, so we kind of just want to have this tiny little program that we want to reference every once in a while. Maybe like I'm bad at mental math, so I want to have some kind of program that this tells me what Celsius it is based in Fahrenheit. So what I have right now is that like Fahrenheit equals Celsius times 1.8 plus 32, right? So we want to get like the Celsius out. So really it's like Fahrenheit minus 32 divided by 1.8 is like the formula to Celsius. And what we want to do is that we want to have like a tiny, very, very tiny program that kind of just like takes my input, then spits out Celsius, right? So what we can do is that well, first let's get the input. So Celsius input. I just realized that this text right here, even though all right, markdown didn't help me out too much there. I'm just gonna do this here so that we can see it very nicely on our, there we go. So we're gonna go our Fahrenheit input. It's actually H right here. I'm missing an H. Sorry guys if I'm spelling it wrong. Fahrenheit. Let me check my notes so I spell it. Fahrenheit. Okay. You're gonna be a little bit correct, input, and we said input before. Then the prompt is that enter your temp in Fahrenheit. Right here. And as I said before, the input is always string. So we want to be doing this right here. We want to be converting it to float. Because if you don't, it's it's gonna say something weird to us later. And our formula is that Celsius equals Fahrenheit input. I'll take up this Fahrenheit here. And I'm just going to convert it almost word by word right here at the top. You can see 32 divided by 1.8, and that's Celsius. Then we'll just print it out. Celsius, go on. Okay, ABC Celsius. Okay, there you go. And now we're done. Actually, we're done, which is nice. So let's say when someone in America says it's 40 degrees, and you're like, oh man, that's really hot. Really, what they mean is that it's 4 degrees. So it's like, oh, okay, all right, some context. Okay, that's good. Which is, yeah, so very simple, kind of like we combine everything that we know. As you see, there's an integer right here. We did integer or we did like a float to integer subtraction. So it turns into float, it divides by float, Celsius is float, and turns this is 4 by 4. And the thing is like, oh man, that's really long. We can actually kind of like make it real nicer. So we can go round. Is that nice, right? It's not round. We call this round function, kind of like how we call the print function, but we'd actually put another number in there because actually, if you see checks around here, we'll put it round in here. It was telling me about a second, so we just put 2 in there so that it's kind of cleaner. We play in there and we go, oh, it's 40 degrees, freezing. So it's 4.4 degrees, which is not, is pretty cold. And as you see right here, it's 4.44 degrees. It's not actually very clear. Like 4.4, we don't actually know exactly what it means. And I'll tell you some fun little thing right here called like an F string. An F string right here is like a formatting string. So put F at the front, and you what you can do is that we'll put this in here. Celsius. We'll run Celsius again. So there you go, and we'll put in here. I'll type in the current temperature. Sure, and you put this block right here, this curly bracket. You put the value you want in there, and now we've pretty much just put we're putting that value, we're interpolating it into the string. This is actually the proper term if you're going to search for it in different languages. It's called interpolation. We're interpolating the value Celsius or whatever it is, and Python will automatically convert it into a string. Because when you do strings like these together, formatting, Python actually does it very, very nicely. Like it just knows, oh, it's a string, or I'm sticking it into the string, so I'm gonna make you a string first. So it kind of like implicitly runs the string function. Let me just double check what Python I'm in. I realized that we might actually crash and burn if this is not Python 3. But give me a second here. I'm gonna add some more niceties in here. Degree C. Yeah, sorry guys. Like I don't know if you can copy paste that one. I'll copy and paste it on the chat if you wanna yes, thank you. Fahrenheit with an H. Yeah, thank you, Daniel. Yeah, and yeah, exactly. String literals, exactly. Template literals, F strings, template literals, exactly. It's the same concept. It's just to have the different names in different languages. So I've nicely formatted this out. I'll play this. I'll put 40 again. Oh, there you go. It's nice. Degree C. Yeah. So this is our first application of it. We'll make something a little bit more complicated. Let's say what we're going to do right now is that you know how it is when like we live in the civilized world, we measure our height in centimeters, and someone asks you, like, you go on a date and say like, how tall are you, which is actually a very bad question in the date, in my opinion. But or like these are the Tinder, when you're chatting on Tinder or like whatever you are, and they say like, how tall are you, that's a pretty appropriate question. But they don't want to hear centimeters, because like you can put a big number and like, ooh, cool, but they want to be feet and inches so they don't get deceived. So we're gonna go feet and inches, a little bit more complicated. And like, how do we do this? We'll break the problem out first, right? So we know 1 inch equals 2.54 centimeters. Then we know 1 foot is 12 inches. And we're gonna try to like build like a way to kind of like from centimeters to inches, right? So what we know for sure is that feet is how many feet there are would be inches divided by 12, right? And at the end we would like this, like we want to put like 12 feet and like 8 inches, that kind, or 5 feet and 8 inches, that kind of deal. Like 12 feet person would be too tall. So yeah, so like the inches is actually very, very specific. Inches, which is actually a remainder is actually has to be what do you call this, like what's this, inches divided by 12, but the remainder of this operation, and luckily in Python we actually have very nice operation for this. So let's start it off with the print. So we'll just copy and paste some of these. Right here. All right, yeah, CM measure, and input your height in centimeters. Come on. Then what we do is that we have to convert it first into inches. So we gotta go inches equals 2.54 times, of course, we actually, yeah, that one. So now we have the inches. Then we want to get the foot first, right? Just like just the foot part, not the after the decimal point, right? And I said before, we have the slash slash, double slash division. It does integer division, and what it means is that it just gives you the integer part, not the fractional part. So we can actually use that very nicely. Feet equals inches divided by 12. So now this would be just the number part, or whole numbers, just the whole number part. Then we want to get like the remainder now, right? The remainder of this operation, and the remainder very nicely can be is very nicely operated by the modulo operator, which is in Python is like percent. So we go inches remainder equals inches and 12, because there's like, yeah, we're dividing it 12, then we get the remainder. Okay, there we go. And you know what? To make it a little bit nicer, we'll round it. We'll round it to nothing. So there's really 3 very important data structures, like basic data structures in Python. Aside from, like you'll make ones out of these, or maybe, like make one for yourself. But there's okay. I wanna do it this way. So it's always nice. Oh, there's wait, look, helping me out already. There's a list. There's a tuple, and there's a dictionary. So what are these? Dictionary. Very simple. Like the list really is, like a list. So basically, like some random items in here, Z, and the list. This is already a list, and this is actually how you construct a list in Python. A tuple you construct with XYZ has very similar interfaces. The biggest difference is that you can't change the tuple. The tuple is immutable. You can't change it. You can't make it longer. You can't make it shorter. You can't change the values inside. It's what it is what it is. And the list, in the other hand, you can make it longer and whatnot. And we'll talk about how you do these kind of things, make it longer and whatnot. And the dictionary is pretty much what it is. Like when it says dictionary, there's like what happens is that this is how you construct dictionary in Python. You put a hash and you put like a key right here, key. You put a value, like an object right here. And when the good thing about the dictionary is that each object you store inside has a key, and the key is how you extract it out. Very similar to like how you like have the index, right? You put 0, you put the key in here instead, and it will get you the 0 out. So let's construct some to kind of clarify this case right here, these cases. So a list is 1, 2, 3, 4, 5. That's a list. Tuple is 1, 2, 3, 4, 5. That's a tuple. And dictionary is 1, like 1. I have to give a key. 1, 2, kind of tedious, but this is what we do to make it a little faster. 3. 3. So if you're very familiar, like this is, like it's like a hashing, like this is like a hash, you use a hash to retrieve the value. That's what it is. Hash map. That's what it is. A hash map is a very good term for dictionary. And I said before, lists can be changed. A tuple can't be changed. So what you can do for the list is that you can actually add to it. So we'll play with the list first. Like what would you have here? Like a list, the append is one of the things you can do. You put 6 at the end, you append at the end. So we'll print list in here, a list right here. And yeah, so it just appends, and like you can actually add a plus another list, because you're kind of like putting 2 lists together. Bam, like that. So it's 6 now. 7, 8, 9. We'll print the list. at this current state. Let's see what happened. What happens? Oh wait, sorry. It returns a new list. So new list right here. That is actually what happens. So you have to kind of, you're not really making the old list longer. You're adding two lists together, but you have to make sure that you're getting that list now. You're assigning something. So you go right here, 7, 8, 9, and yeah, there's a lot of these kind of things that you can do for lists, and you can change it. You can actually even do what we've done for strings, and we'll talk about how similar they are. They're very, very similar in terms of how you kind of like think about the data inside. So a list, you can actually get what's the first, the 0th one, you can turn to 1, right? It's very simple, very similar. Sorry, not simple, but it's very similar. So you can actually go do the same thing. So 1, so we're starting from 1, 1, 2, 3, 4. We're gonna get 2, 3, 4. So 1, 2, 3, and 4 is the one we're gonna ignore. So put it in there. List slicing is the same deal. Like it has the same interface as the one you have in the strings, which is very, very nice. And as you see, the plus right here works like a string. You add 2 strings together, it becomes another string, right? And what I'm trying to get at is that like they have very similar interfaces because they're very similarly defined inside Python. And the tuple is kind of the same, although the tuple you can't change, right? A tuple equals, we'll just make it short, 1 to 3. But if you want to add like a tuple dot append to, it doesn't work. Like it doesn't work because there's no append. You can't append to it. If you add them together, what really happens is that actually I have to double check this because play that one. It makes a new one, but actually it makes a new one. Kind of like how this works. It makes a new one. So it kind of works, but you don't actually change the original tuple, right? You don't change this tuple here, like new tuple right here. So if we print the new tuple out, print new tuple. We actually didn't change the old tuple right here. We didn't change it because it's unchangeable. It's unchangeable. But yeah, so like you can't kind of like expand it. You can't contract it. A list, on the other hand, you can't do. You can do that. And I'm trying to go back to like the concept of like the strings. If you realize, actually, I just want to I just want to reiterate what you can do with tuples here is the same as what you can do with strings or with like lists. Is that you can even do this logic right here. It's gonna double check if people are not following. I'm not sure about the data frame. I'm not sure what you mean by that. But yeah, we'll get back to that. I'll ask you later. But so the tuple can also do this, this nice slicing. And the reason for that is because they're all represented very similarly in Python, and they have really have the same interfaces, because like like the string really is like it's almost like a list of a list of chars, and 1, 2, 3. They're all the same, right? They're all like they're in the proper terming for this is they're iterables. They're all something that you iterate to, so they can share some function actually shared between them. And that's like the good thing about Python. Like certain things will work the way you think it work, especially if people have been really diligent in implementing them. So like someone's been diligent. Oh, lists look like tuples look like strings. Why don't we just share the same API to all of them so that we can like too much headache on like why is the interface to access strings different from a list, when really they're the same thing in terms of like how you represent them abstractly, right? Okay, so I'm going to talk about like this really special one called the dictionary. And the dictionary basically still has the same interface. You still use sorry, give me a second here. We use still the bracket notation to grab stuff out of it, but we use the keys instead. And the keys now is 1, right? And we put 2 in there and 2 and whatnot. And yeah, so like there's actually a lot of ways to kind of like convert them between each other, but we don't have to talk about it right now. But yeah, the dictionary really is just that. Like it's a hash map. You put in like the index, you get the thing you stored into out, and it's very flexible in that you can actually store other things in there. So so we'll copy these two guys here, and let's go crazy right here. Go a list is a list, a tuple is a tuple, and yeah, and we can even add another dictionary in here, another dict, which is, you can actually reference yourself, but let's not do that today. A is a terrible contents of a dictionary in here, but B, and this is completely valid. Like dictionary is a very flexible data structure in that you can do this. You know, like it kind of prints out, oh, there's a tuple, there's a tuple in there, dictionary. Yeah, it's very good. It's kind of like a struct, struct in C if you think about it, but yeah, it actually kind of is like it. But yeah. So like you could store a lot of things in there. But yeah, so these are for basics, the basics that we have. Whatever you can do, like there's a lot of like funny. There's a lot of additional things that you can do with lists. I'm gonna go back in here. Just to kind of like add a little bit of things there. I kind of jumped over it in my notes. I have like a flow of notes, then I didn't follow it. So now we're kind of, this is happening to us because of my own fault. We can actually put other things in, like a pen, you know, like there's an append for sure. I read it in there. And you can insert very specifically to an index. So we want to put at the start 0. We want to put a 0 right here. So put 0. And we're gonna put the value, so index and 0 objects. And we can print the list now. And let's see what happens. So there's another list with 0 inside. And as I said before, like the insert actually changes the list. You can't do these operations for tuples, just to kind of reiterate that. And like one thing I forgot about the strings before, and someone had pointed out very nicely in chat, thank you about that, is the length functionality. There's length right here. As I said, like tuples, lists, and strings, they share a lot of APIs. Length is one of those. So you press that. And actually, a lot of things actually share that API. You can just see 7, 1, 2, 3, 4, 5, 6, 7. There's 7. Perfect, right? But yeah, this length, a lot of like things share this API. So you can use that one. Okay, so we're talking about these like iterable types now and whatnot. And sorry, I'm gonna delete this, and we're gonna go to the next part here is loops. So I'm talking about iterables, and iterables is something you iterate to. So naturally, something you iterate to, you're gonna go through with loops, right? And there's two constructs for geez, what are you doing, Pete? Okay, here we go. There we go. Okay, there's really two main constructs for loops in Python. So I'll copy these. Like you'll find something interesting here in that like they're all similar in terms of string. Okay, they all answer to the same API. So there's a while loop, and what you do in the while loop is that while excuse me expression right here. So let's say some variable. The thing about while is that it's very manual, so you gotta like a variable, right? A var equals none right here. So you're gonna go or 0, put 0 in here. A var is greater than 5 or greater than 4. Then sorry, wait, sorry. It'll only execute while this is true. It'll always execute when this is true. Okay, so a var is -4, less than 4. So a var is 0, initiate 0 equals 4. Okay, that works. So we go in, we start the loop, right? And we want to like do something about this a var. So a var is a list. We just go a var in here. Actually, we want to like we actually want to like start it there, because 0, oh actually, yeah, it's fine, 0. And we kind of like getting like that value right there, right? Then yeah, actually, wait, I'm not following my own instructions, so we'll print something in there. Sorry guys. I'm not following my own instructions. So I'm gonna go kind of
name the avar to index.
Index. Actually, yeah, you're right. Yeah, you're right, Carson. You're right. We'll use index. Okay. Because like I'm not following my instructions, my notes for some reason. I don't know what's happening with myself here. Sorry, guys. So Carson's right. I'm actually using the avar that as an index, so we'll just name it as index, and we're gonna print whatever is on that index right here. And what we're gonna do is that we always have to update. Like how loops work. We have to make sure that there's like a thing that we change, or else like we're kind of index plus 1. We're kind of gonna go in a infinite loop, right? And I've actually done like something like index plus equals 1. This is actually just a shortcut to like index equals index plus 1, but I didn't discuss that a while ago, so I can't really do it now. I'll just put it here as a note. Then yeah, this actually is a basic while loop right here, and we'll just play it very quickly and kind of goes around. And if we actually don't add this one right here, it'll crash. So we wanna stop that. Oh geez, yes, I've definitely done bad to this here. So we're gonna refresh. Leave page, yes. So we've done bad to it. Don't do that. Unfortunately. Oh,
That's
okay.
A danger of infinite
yeah.
loop. So
yeah.
never do that, please.
Yeah, never do that. Make sure. So the while loop is kind of dangerous in that it's manual in every sense of the word. Like this is the only thing that stops it. And you want to make sure that you have your like your updating operation, or else you just saw what happened. And while loops are dangerous in general. So like I suggest you don't use the while loops, especially if you just have like this iterable right here that you want to use. We can use for loops instead. A lot easier to use and a lot straightforward in syntax. So what you do is that what you're doing is for a name, or put name like a value, and I'm gonna go in my list. So a list. So what I'm doing here is that put pass right here. Pass is a special keyword to do nothing, like no op. Don't do anything. So what I'm doing here is that from each of the value list, I'm gonna take one out, stick the name into and value. So it's gonna be assigned to and value, and you can use that value already in your block right here in here. So let's go print. Oh geez. Print and value, and these two are pretty much the same functionality. And as you can see here, I didn't have to start an index right here. I didn't have to have this truth operation right here, like this conditional right here that I need to make sure that it will terminate the block, right, loop. I don't have to do this operation. I just have what it does really is like it just goes through the entire list. So if I play this, does the exact same thing, although we can't really say. I'm gonna print like a nice little right here. So right here, it's exact same thing. Amazingly, like they don't do too much of a lot of like errors and whatnot, right? So that's really it for loops. Like this is like the most basic loops. Like if you be super fancy, I'll teach you another way to loop, but we'll do that after one other part here. I'll talk about it after functions. So so we'll talk about functions now. So we'll talk about functions now. Like we always want to go make sure that we're here. Functions, okay. And what functions are in Python basically is a set of like a block of code that has its own scope. And what scope means is that it's its own pretty much universe, like its own context, its own variables that lives just inside of that code block. Then you have inputs to that function, and you use that as like a reserved name, and that's like I believe the exact word is like actually I forgot, like in the variable, something variable, but don't quote me on that. So example function. So we'll make a function right now, and to make a function, this is actually this is a function already. Like for the identity function is that there's a def. The def tells Python that the next value right here I'm gonna have is a function, like a name of a function. Then what we put in the parentheses are the inputs, but in this case there's no inputs, so we don't put anything in there, and we're gonna put the names there. And inside in there, the password is the block of code where you run, different another set of Python codes. So let's make a more complicated example in that, like I'm gonna put input A right here and input B right here, and I'm gonna go. Want to return something. So amazingly, Python just says, return input A plus input B. So we've made like a very simple function right here. We have two values, two inputs, and then let's try it out. So I'm just gonna print example, and you know what's really nice? Why don't we use the actually, you know what? Yeah, let's use the input. So input A, input 1. Try to make it a different name. We're getting kind of confused in here now, and I'm gonna wrap it as an int because I don't want it to crash. In value for input A, then we'll copy and paste this. So input 2 value for input B, then we'll just print the value right there. An example, input 1 and input 2. So when you see me use it, the values of input 1 and input 2 will get, sorry, I'm using my fingers, but you can't see it, unfortunately. You can see the input 1 right here. I use it as a argument to input 1, and the value of it is gonna get assigned to input A within this block right here. And the input A only lives, like the value of that input A only lives within this block. Outside of it, it doesn't actually care. So we'll play with that in a second here. So first that, so like 2 and 3, this is gonna be 5. So and I was saying the scoping is very, very important for functions, because like you can actually define some input A right here. Input A equals 5, input B equals 3. Then we'll take this example out. Then we'll go right here. This input A, input B, and like we could actually do something like this example, and we're gonna put like 1 and 2. So we're kind of like overriding input A, input B with 1 and 2, but still there's still input A, input B right here, right? So we're gonna go right here, input A and input B, the same naming, everything same naming, and it's gonna be okay because this input A and input B only lives within this block. It's encapsulated completely in here. So you play in here, and it's still this like input A, so it's 2 plus 1, right? And it still kind of maintains the value right there. I'm just gonna double check if people are getting confused right here. We don't actually have to return one value. It's very technical how Python does this return value. Thank you guys for answering questions, by the way, while I'm kind of talking, because I can't hear anybody. For functions, you don't actually have to return one value. You can return 2 values, and the way you do it is like this. So we'll make a new code block in here. Def example 2, input A, and input B. And this is gonna be like complete identity function. So I'm gonna return input A and input B. And this is actually quite a very specific Python thing. Because what you're gonna do is that, some A, some B. This is how you kind of like return it. 1 and 2, and expect that some A is gonna be A, and some B is going to be like whatever you return in the second argument. And this is actually called tuple unpacking. And why is it called that? Is because this return value right here is actually a tuple. So this is actually equivalent to like return input A, input B. Then we're kind of just like this tuple packing is like if you have the number of like here, the number of names here is equal to the length of the return value here is gonna kind of like nicely map it together. But you're not limited to one return value. Just like it's done within Python with its own tricks, which is nice. And someone's asking separated comma. Can you return? Yeah, separated comma. Yes, exactly. That's exactly whatever I'm saying right here. But yeah.
So I want to extend this a little bit.
Yeah, for sure.
You can return multiple values, like not limited only two, but you can return like a whole number of different things, and they're in the tuple size. I mean the type. So when you do this unpacking, you can do that directly. But the thing is, the best practice for objective-oriented design is that each function does a single thing. So it is best that you return a single value. So in the future, it's more scalable, and you can decompose your complex function into multiple functions, so you don't have to return multiple values. But yes, you could return multiple values from a single function. And also, Peter, do you want to quickly talk about the dictionary? Because I see some confusion.
Oh yeah, of course. Yeah, let's see. Let's go back in here.
Unless you want to cover it later, if you have that in your mind.
No, I don't have it. I think I've just finished the dictionary part. Let's see what questions people have for dictionaries. I was gonna go over the top. I'm gonna answer very quickly Lisa's question. You can stop an infinite loop. You have to press the stop value here very aggressively, but it's definitely very hard when it's going as fast as you can. Yes, it really depends on like what environment you're in. And let's see what people have questions for dictionaries. Yeah, thank you, Daniel. Enumerate is a very good way to kind of combine them together. Very nice. Can you call a dictionary in for syntax increment? Yes, you can. You actually can. The weird thing about the dictionary is that when you iterate through it, like we can actually check. We could always just experiment. Okay. So when you iterate through a dictionary, we're actually iterating through the key in the dictionary. So I'll do this right now. So like this is technically we just return 1, 2, 3 right here, because when you iterate through dictionary, it's definitely an iterable, but yeah, it's returning you a key. What you can do if you want to do some other thing is that you can go items, and you can this will actually return you key and values. This is how you can. This is related to like tuple unpacking again, because the item returns you a list. This items right here will return you like something like this. This is what it looks like. Key 1. Yeah, 2, 2. This is what it would look like if you do the items actually. Sorry, and it kind of like just does this value right here. So I'm gonna write the different ways to do this, so that people can reference this later. In key and value right here. Let's put comma here. You can actually print like this. So as you can see, like 1, 2, 3 right here. So that's how you can iterate to the dictionary like this, and you can iterate this as well to go, like a dictionary. Oh geez, a dictionary and the key. So you can go like that. So they have the same output. Yeah, that works that way. If you're showing different things, cutting and pasting.
There's also
you're right.
Method that I can use.
Oh yeah, it's actually thanks to reminding me for that one. So there's actually another one. We go values of value. So what's happening in the values is that it makes a list of just the value part. So we can go print value right here. So I'm gonna do it right here is that ordinary iteration, values iteration, and values key and value iteration. And I should actually print something like this. Key val just the val, and just the key right here. So you have lots of options, which is nice. I'll play it now. The screen is kind of too big. You can't fit everything, unfortunately. But yeah, you can. There's a lot of options for it. So the value ones, you 1 to 3, the key val ones, yeah. Unfortunately, this one, we'll delete this one right here because kind of confusing. Okay. So if you do in dictionary key, yes, exactly. Key, yeah, exactly. It's not multiple value, the trans tuple behind the scene. Exactly. That's one of the things about Python. It uses a lot of these techniques within itself. Unfortunately, like, like it's kind of, it's good, but maybe some mystery magic is, kind of like hidden behind it. But yeah, there's a lot of Python stuff is done through tuples and whatnot. Do you guys still have any questions about dictionaries before we move on a little bit more for some function examples? If not, it's cool. So there's one more thing I want to talk about the example like functions is that we put input argument here, but there's actually another thing called a oh yeah, you're welcome. There's another thing called like a keyword argument, and the keyword argument, what it really does is that it gives a value to okay. I'll get back to this. I'll get back to your question, Vanya. But the very quick answer is that technically, yes, because as I said before, dictionaries is just an object as much as everything is an object. An object has a reference to this within itself. In Python, the this is self. And the next lecture would actually clarify it a lot. Carson and Keegan will talk about it a lot more. But it gets complicated in this because like the dictionary is a very it's a basic data type, but also it also is under the paradigm that everything's an object. So it's actually from a class, and the class has a reference to itself. So it's quite funny. It's quite a funny concept to think about because like it really follows its creed. But okay, let's get back to the example. The example function right now, I'm going to talk about keyword arguments. Keyword arguments is a very easy way to do default values. So for input B, I'm going to put a default value of 1. I want to make it to like a successor function. So what I can do is that basically, so I could actually just go return input A and input B plus input B. And what happened now is that I can actually call this. Get out of here. Okay, there you go. I can actually call this function without the second value because I've already input a default. So I can just go 1, yes, 1. Then like you can still do this because it's the second one in here. You can put 1 in here, or you can put 2 in here, so it's going to turn 2. But also, like amazingly, you can do this as well. You can actually specify it. So let's say you do something else like this. Input C equals 1, right? And you kind of end up being like input C is a multiplier, right? Sorry, I'm gonna not do copy and paste. So input C is a multiplier. Behind the scenes, you can actually use it as like without the input C being changed, it's just a normal addition, right? So we can actually put like addition. Like this is just normal addition without like so without the input B, it kind of seems like a successor function. Successor being that like if you put n, what's the next number to n, which is n plus 1. So with the input B inside, input B being 1, it's just a normal addition. Then if you put input C inside equals 3, let's make something there 5. This is a multiplication now. So and the thing is like you don't have to define them. Like you kind of change the behavior of the function in multiple ways because you've just changed the defaults and whatnot. And like a lot of different, like this is like a really weird way of doing it. Like I wouldn't like make a function that does 3 things depending on the input. That's kind of like crazy in my opinion. But you can do it. You can do it. If you want to be crazy, you can do it. So let's check out the output in here, so that always nice to see what's happening in here. And yeah, so we actually have like b equals 1, so it's like, yeah, this one is like we can make a 0 in here so that it actually does this properly. Yeah, there's a tiny bug right there. If you saw the tiny bug, and I put 1 in here, unfortunately adds 1 in here, so it's gonna be 6 instead of 5. Yeah, but sorry about that, guys. But yeah, so I just want to kind of reiterate what keyword arguments are. They're basically just values that you can have defaults for. You don't have to explicitly define them, and you can have them together too. Like if you want to have like a very complicated function right here. So sorry, I'm gonna type it out so that you can follow through. So start 1, we're gonna add 2. So input b equals 2, then go input c equals 3. So we're gonna add 1 plus 2 first, which is 3. Multiplied by 3 is gonna be 9. So the last value is gonna be 9. So we kind of, we can kind of like have nice defaults without, yeah, it's just basically nice defaults and like things that you don't have to worry about if they're always gonna be like this, and you could customize it a little bit. So that's it for functions. And one final thing here, I told you we can do like a fancy loop, and you can really do that through recursion. And like this is like as an aside, you can use your function inside of your function to kind of like do more things. So let's just do this here. A list right here is 1, 2, 3, 4, 5, right? And we're gonna go make a for loop, and we're gonna go with a list, and we're gonna use like a default index, right? Index equals 0. We gotta start at 0. And what we have to do is that we're gonna print a list. Oh, I'm gonna make this input list. Sorry guys, I'm gonna put this input list so it's not confusing. Even though it works, like it's not. Yeah. Then we're gonna call. We're gonna call the for loop. We actually don't have to call return. Like if you don't call return, it's okay. The return just returns something. If you don't return anything, it's gonna do none. So what I'm gonna do here is that I'm gonna do for loop again. Again, input list, and the index equals index plus 1, right? And I might do a bug here in second here, but yeah. So the important thing about this kind of way of recursing or like looping through something, an iterator, is that you'd have to make sure the base case is always set up, like or like how you're gonna terminate the loop. So if the length of is what's this, like, is equals index, he just return, because like at that point so this is like, what's the length? 1, 2, 3, 4, 5. There's nothing in the 5th index, right? Because the 5th index is going to be like, like 0, 1, 2, 3, 4. This is a 4th index. So there's nothing in the 5th index, so it's going to crash. So we're going to return before then, right? So let's call this out. For loop and a list. Then just run it. And it just pretty much does what the list does if you have the print as the block. So yeah, this is just a different way to do it. You could call your function inside your function, just as how you would learn it in like your classes, computer science and whatnot. This is just one exotic way of doing the loop. And thank you, Daniel. Yeah, spread operator. Yes, exactly. Um, yeah, like I sorry, the guys. I didn't know that a lot of people here are good with JavaScript. I could have used like better analogies like that. But thank you, Daniel, or Daniel, yeah, for pointing these out. For pointing these out. These are great. These are very good analogies. But yeah, this is an exhaustive way of doing the loop. I suggest don't do this unless you really have to, because Python will stop you at one point for getting too deep. But one last thing that I remember that I have to tell you guys is that there's one thing called a lambda. And a lambda, what it really does is that it lets you define a function in one line and a function with no name right away. So I'll just go with x plus 1. The anatomy here is that lambda tells you, I'm going to define a function. I'm not going to define the name. I'm just going to define the argument right away. So the argument is x. And after the colon is what we're going to do, the body. Right, so you can actually do this to xy, x plus y, but we'll just do, so that's like one example. This makes a function, this is equivalent to def sum func xy return x plus y, where what happened here is that, it implicitly returns whatever this value is going to be, and you can only have one expression here. Very important. You can only have one thing that you can only, this only can only be evaluated to one thing. You can't have like 2 lines in there or whatever. And like this lambda x plus 1 is functionally equivalent to this sum func to x return x plus 1. They're functionally equivalent. The only difference is that if you realize here, there's a name, right? There's a name right here. So when you call this sum func right here, sum func, you call sum func right away. So, and like this is how you kind of refer to that function. The lambda is that you have to assign it to a name. And this actually, if you I want to remind you again, Grandmaster Fun, remind you again, is that everything in Python is an object. Even functions are objects. And because they're objects, you can assign them to a variable. So right now, a nameless function, func, because we're the grandmasters of func here. And we can assign it, which is nice. It's like, so now we could actually call this right here, and they're functionally equivalent. We just kind of went a roundabout way up to defining it. So right here, so two, they're pretty much the same. But yeah, just to make the big difference between lambda and like a normal way of defining functions is that the more normal way of defining functions implicitly asks you, or explicitly asks you, not implicitly, explicitly asks you for the name when defining it. But the lambda lets you get away without naming the function. So you can actually assign it to whatever name you want. Or you can even assign it as like some variable, or some input value. And just it's like to kind of like what do you call this? Hammer down the point that everything's an object in Python, which is one of the best things about Python, right? We're gonna use the function as an argument. So I have this here, a function runner, func runner. We're running some cool, good funky things in here. Func input. And what we're gonna do is that I'm gonna go func input, and I'm gonna run, and this is gonna run it. So that's really our function. So I'm gonna define a lambda. So like some I'm bad at names, which is maybe a sign of like something. But we're gonna go. Unfortunately, there's like no input in here, so we're gonna try to put an input of 1 right here, right? So x plus 1, and what we're gonna do is we're gonna run the func runner, and we're gonna make the func runner, some func right here, and it's gonna run the function for us. So it's kind of actually, yeah. Although like this actually doesn't return anything because it just runs it. So what we can do is that we can actually print. We'll do this print right here, so that we know the func runs the func. So the func runner runs the func, because yeah, I'm gotta getting confused with their own names now. But okay, we actually need some value in there. Okay, so we've done the same, like run right here. We're kind of like yeah, we're sending the function into the function runner, and the function runner runs the function. It's just kind of like, just think about it as being the same thing. They're all the same, so it's nice that way. Okay, finally. Okay, one of the most important things in here is that there's some bugs in there that what happened right here. I'll copy and paste the code above right here. Print x plus 1, right? And when you saw me like very quickly just ignoring the error, right? So play this one right here because it goes type error, right? And we're changing topics if you haven't realized. We're right here right now, errors with sessions. Just to kind of like reinforce where we are. So this happened to me a few times today. I play it out there, and the function halts. Just halts and tells me some, the stack trace back, all these kind of like, words right here that, maybe some people know very intimately. Some people have no absolute idea. This is just basically what it's saying is that what's wrong with your error, right? What it's saying here is like, I have a type error, and this is the functional state of the program when it happened. And when I'm running it, so this is the interpreter telling you I'm running the function in the third line, which is right here, which actually shows right here. Some func crashed because the lambda function I made is missing one value, because this lambda we're expecting 1x right here, right? And what's really happening here is that like this is what we call an exception. An exception is like a bad state that we didn't actually take into account. And you're going to come across this a lot. So this is actually a very important thing to kind of know into how to deal with this. Well, the first thing you have to deal with this really is that, handle that path. But in this case, it's like a function, like, what do you call this? It's like arity path, arity error. Like arity meaning the amount of arguments to a function. That's what arity means, if you come across it. But yeah, so like there's an arity incompatibility. Like some func expecting one argument, but you passed nothing. And like let's say like somewhere long far part in your code, like you just can't give an argument. So what we can do really in this case is that there's a construct called try that try. Then there's a block with it. Then except. The try except has to be together. This is very similar to the try. What do you call this in JavaScript? Try something. I forgot. Sorry. Daniel, help you out here. Try catch. Yes, exactly. This is try catch. The good thing about try catch here in Python is you can define exactly what you're trying to catch. So in this case, we want to catch the type error. But if you take this out, it's completely legit. Like you can actually print here, I made a mistake, right? So I read in here and I made a mistake because, like what really happened is that, I failed in func, except is going to catch it, and whatever is in the except clause, it's going to run. So that's great. That's great. Yes, very true. And in JavaScript, I'm a full stack developer, so sometimes in JavaScript I would catch everything, and oh man, there's some proper headaches from catching everything. And this is actually the point I'm going to try to make. Exactly, Daniel. Exactly. This is exactly what I'm trying to make right here, is that when you try catch something, you have to make sure you know what you're catching. So I'm going to go right here, type error. I am only catching this type error, and I can actually make a very nice, very, very nice error here. You're missing your argument. Yes, don't catch the ball. Perfect. Exactly. Yeah, so right here, I want to put your right here, but this is, yeah, you have to escape because Yeah, I didn't talk about that, but that's how you deal with it. Yeah, so I'll just put it here. But yeah, you have to be very explicit with what you catch, because like sometimes some errors will be like very different. Let's go over here. So we'll change this print to print, right? Okay, so print doesn't exist, right? I didn't define some function like print. So go in here, actually type error. That's actually right, because if you run this is the same error. This is actually the same error, because it's this type error. I'm doing the wrong call here, because it's the same error, unfortunately. Let's find something then a different error, like a value error. How do we do a value error, or like a? Okay, let's pick a new example. This is probably better. So we have here, we made a function here, failing function, and we want to find this what we call this value 2 right here. And in this failing function, or value some number, actually we're going to find some number, right? In the failing function, it has an internal list, which is equal to like 1 2 3 4 5. Then I'm going to return the index of this, and I said it before, internal list and equal index of the sum number, right? So the good thing about this is that if you run this with the value 1, it's okay, it'll return you 0. But if you run it with something it doesn't know, it returns value error, right? Yeah, so like we want to try to catch that value error. So 3 4 5, wait, except a value error, then we can just go like you don't have that number. Print, we don't have that number. We don't have that number. So now, like, it's a nice error. But let us say like you made a mistake right here. You put like indie right here, and it's a value error. Like that's a type error. So you go over here. Now I made a mistake, type error. Like list doesn't have attribute, so attribute error actually is attribute error. So it's different error, not type error, attribute error, which is nice. Like okay, we don't have to worry about that one. But if we actually do this, it just catches everything. So like we don't have that number, okay. Like, and you put like something that you know for sure, put 1 in there. We don't have that number. Like, what? Am I going crazy? Am I going crazy? So yeah, just to kind of like iterate how dangerous that is. Yeah. Okay, so people are okay. That's yeah, true. True. It's actually not a random label. That's actually very good observation. It's not random. There's actually some very, very specific ones that Python defines. There's a value error. There's a type error. There's a what do you call this?
Attribute error.
Attribute error. Yeah, there's a few. It's very specific. So when it comes up, you can just copy and paste it, and you could copy paste right away. But sometimes you can actually define this very specifically. So I'll show you something right here. So we have this function again. This one always complains, right? And what we're gonna do is that we're gonna raise an error, and this is how you actually raise the error inside. We just raise some value error, right? This is how you do it. But I'm just doing this as an example. But like you could actually define your own. But actually, you know what? I just realized that I'm overstepping now. We just reserve it for next time for Carson. Carson, make sure you guys do that, right? So now you can actually do this. Like the errors themselves, like if you're wondering how the errors are being called inside, it's actually just exactly like this. Like it just raised. The keyword is raised, and you put in the value, the error that you want. Then you can actually do this now. So this one always complains. This one always complains. You call it. Except value error, right? Then print. We're good. We good. So now it gets caught. But if you put something else in here, attribute error, doesn't get caught. You know, sorry, attribute error and whatnot. So this is like the basics of the attribute error, value error. Yeah, okay, yeah, exactly. Because we raised the value error, we stopped right there, and it didn't catch it. So it's not. We're not good. We're gonna complain. We're gonna complain for sure. And yeah, that's pretty much it for try except. There's actually a few ways to do this. You know, like you can actually. There's one more thing I can do. Like you could put this right here, like this, a comma, and say if we get attribute error, it get value error. You know, catch it. That kind of deal. Or actually, how do we do this? You have to do this, I think. Give me a second, or maybe I'm living in the Python. Yeah, okay, there we go. Sorry about that. I missed the explicit tuple tuple definition. But yeah, that's how we do it. Like if you want to catch two different things. So let's say like sometimes you know, you put attribute error in here this time around, you know, it's still caught. It's still caught. Okay. So finally, we don't have a lot of time, unfortunately, but we can do a very, very simple to-do list with all these things that we've done, right? So what we can do right now is that, you know, we can define, like, we'll make a list first, like our to-do list, right? And you know what? Let's make it into a list. This list for sure, because this list. And what we can do is that we can define a few functions to do add. So we add to list and item. Then we'll just pass for now, and then the remove from list item. Then finally, what am I supposed to do? When we go a list, item list. Pass. And if I've actually forgotten some things in there. We have to put the list in here. How can we insert something in item? So item list. We'll put item list in here too, just because we need them, right? So what should we do to add to the list? And that's pretty simple actually. We just go item list dot append, right? And we go to item. Then how to remove the list? Let's double check our functionality. We have one called remove. Amazingly, we have one called remove, and we can do that. We'll just go item list dot remove and the item, and expect this to have some error. So we got to use some of that skills that we just learned. Then finally, for the last thing here, for item in item list, we're just gonna print out the item, right? Or the item, not the item list. If you want to do it per line, but also you can do it like in one go. But yeah, so that we have this nice. Let's do this now because this is pretty awesome. Because like now we can just go. We'll do this crazy while loop right here, while true, and we're just gonna go. You know, we're just gonna go infinitely add. So while true, input new task equals input thing I want to do. Then we're gonna call our add to list. Then we go new task. Then we're just gonna, you know, we're gonna call like what am I supposed to do right away. Am I supposed to do? Then we're just gonna go our to-do list. But actually, if you see right here, like I just copy pasted that. Sorry about that, guys. Our to-do list. Yeah, there you go. So when I run this, it's just gonna fill up my list over and over, like sleep, study, work. Yeah. So that's a nice to-do list. Very, very simple. But we don't actually know how to delete, unfortunately. So we'll stop it for now. And it has a keyboard interrupt. But yeah. So what we can do is that, like, if the new task is to delete item, very specific word, what we can do is that we're going to ask for another to delete equals input what should I remove? And then we go remove from list item to delete. Then our to-do list. Then we'll print out our thing again. Actually, we'll go else right here. There you go. Then we can just reuse this one right here. Okay, so we'll play this. Okay, or equals. Sorry, guys. Equals. I just assigned it, but really, what we need to do is a expression. So I want to sleep. I want to eat. I want to delete item. Okay. Or what should I remove? Let's go sleep. Eat. Okay, that's good. I want to remove wash. But the thing is like, oh, sorry, delete item. Then I want to remove what do I have here? Just make sure that edge case. Like go to school, to school. And we'll actually have an error. It's like, oh, by error. Oh my geez. Remove not in list. So what we can do really is that, we can go try. Except, what's our error? Value error. Okay. Value error. Very nice. We'll load that one. Then we'll just go. I'll just print. Print. Wait. Slash. You're not doing that yet. Then that's it. We just pretty much took care of that one. So what you want to do? We want to eat. We want to sleep. We want to delete something. Item. And we delete, school, but it's not there. So you're not doing that yet. And eat, sleep. So that's really like, I did this super fast, unfortunately, guys, because the time's almost done. I want to answer your questions, but you just made like a very, very basic to-do list right here that didn't actually use dictionaries in the end because I didn't have enough time. But I'm sorry about that, guys. But I will give you another example in this with the dictionary. But yes, I'll end this up right now. I was going to give you, I was going to reiterate that if you weren't able to follow very quickly or as with my pace, unfortunately, because I do talk fast and we're running out of time. This right here, I'm going to give this to my colleagues, my team members right here. This sheet right here. I'm going to give you another one, which has a cleaner, just completely documented version of this. You can just run through. So you're going to have two different files that you can look at. And I'm going to clean this up first so that, it's a little cleaner and whatnot. And, there's not, like I could put some more documentation in there. But yeah, that's really what I'm trying to say. Just, like, don't worry about it too much if you didn't follow. You're going to get this anyways. And, like, I believe in you guys. Like, you guys read through this, you're going to be Python experts very soon. So I'm open to questions at the moment. Although we don't have a lot of time. I know you guys are probably busy. But, so I'm open with questions. Open for your questions. I'll be here for the next, 10 minutes. And welcome everybody. Thank you for listening. Thank you for your patience. Maybe I make a lot of mistakes and a lot of people. And I want to thank my team members right here covering my back. Thanks, Daniel. Thanks, Carson. Thanks, Lee. I'm not so sure other people are here within the team. Thank you guys for covering my back and helping me with better analogies. And were you say Carson, or was it said something in the back here? Sorry, I didn't call you.
Much appreciated. Yeah. It's a really nice effort.
Okay, so I'm gonna answer someone's question right here. How do you delete items if they're the same word but not the same syntax? Or same. You know what? They're not actually gonna get deleted. And like showing you here is that let's read right now. So we go school and school. It's actually two different things. If you delete something, delete item, and you go school, you'll only delete school. Because they're actually two different things. What you can do in this case is that you can use another function. You can go item dot lower, so it's always it's always lowercase. And you'll actually kind of realize that, like, if you do this right now, school, it's always going to be school. But if you put school again, it's going to append it. So it's there already. So we actually have to add another one here to kind of like take care of that case. So we're going to double check in here. If item not in item list, and we can append. So now if we do this, so school, this goes usually school, and it's not going to add it because it's already there. But yeah, that's, you know, n being in checks for membership. Membership. If you use this in a dictionary, it'll check the key, just letting you know. Let's see. Okay. Okay. All right. That's for you, Jen. Lisa here. String ABC. Still don't quite that C does. Oh, like for the. Do you mean the like this, something like this? A list is one. I'm just gonna make the list right here. 1, 2, 3, 4, 5, and like when we do this, right? List is like 0 to 2 or 0 to 4. Then there's the last value right here, right? The last value here is the step. So what you're doing here is that, like, so we're starting at 4. The default value this is 1. So we're gonna go up to the 4th index, so 0, 1, 2, 3, 4, so 5. But we're gonna step 1 at a time, like this. 1 here, then afterwards this one here, then afterwards this one to 3, then this one to 4. But if we put 2 in here, we're gonna start with 1, then we're gonna go 2 steps, 1, 1, 2 to 3, 2 steps, 1, 2 to 4 to 5. So that's really what it does. It's kind of like tells you how big of a jump to the next value you're gonna take. So this one is gonna go 1 and 3 because it skipped the number 2 in here. So yeah, so like I guess like to kind of like make it clear, super clear in here that there's a picture. I should just use the picture right here, right? 2, 3, 4, 1, 1, 2, 3, 4, 5. So like we have like the thing right here, like A, B, then like let's say 2 right here. What I'm doing here is that if A equals 0, so we start 0 right here, and B is just the end. We go 1, 2. So the first one is 1, then 1, 2, so 3, then 1, 2, which is 5. That kind of deal. So it's just a step size. Okay, I'm gonna go up. My wisdom, you're not Pokemon trainer. Yes, yeah. I was pretty bad at Pokemon. I used a lot of rare candies. So don't be like me. Don't take the shortcut. Just curious, would it be possible to get a copy of questions in ask and chat? Yeah, actually, not my call. I guess I can copy and paste it, but are we able to do that, Zinli or Parson?
Yeah, we'll do that.
Okay. All right. And yeah, you're welcome. You're welcome. I don't know how to say your name, Ying Tian. I don't know how to say your name. I'm sorry if I butchered it. But you're welcome. And everybody who said thank you, you're welcome. I just said that one specifically because I saw it right there.
Daniel is asking, Peter, is the art created in this class going to be sold?
Oh my word. Well, yeah. If you want to buy it, I'll definitely sell it. I would go for an auction because I want to maximize that. I want to maximize it. But like there's bad pictures right here. I can make a screenshot, although it's
That's
quite.
Gonna buy it for those cats.
Look at this, like this animal. You guys like this animal with no head. Okay, we gotta answer this Julie's question before we go on. If I have an error in this part, can you help me what I did wrong, please? Type error.
Someone
Error.
answered that actually.
Okay, all right. Thank you. Okay, thank you to that person. Between list and arrays, what is more efficient data structure? In Python, list and arrays are basically the same thing, unless because like I think of an array as a linear data structure. They're pretty much just like linear pieces in memory. So they're pretty much the same. If you think about tuple and arrays, wow, that's bad handwriting. Tuple and arrays, or lists, sorry, the optimization is very different in that like they still take the same space, but the way they kind of like, you know what, this is quite advanced topic for me to be honest, but the real gist of it is that, you know, like the tuple can't be changed. So the way they optimize this is that like they put it in like certain places that they can kind of like, they don't have to worry about bridging to the next part. Because like list has to be adjustable the size. So you have to make sure that there's enough, you know, memory size to kind of like cover the thing, right? At least give it like a you know, like a different area. But the tuple is like very static sized. So I'm not answering that question right. I gotta have to research it for you because I can't really remember the big difference. But there is like a performance difference between the tuple and list. Very, very big difference. Yeah. Thank you, Daniel. This is definitely yeah. Real Python is a great place to check out like good tutorials. They're relatively easy to digest, but also very thorough. I was talking about variables. I took like maybe 5 minutes, but if you check out the variables that they discuss, they're very thorough. They probably take you like a, you know, 30 minutes to an hour to read through that documentation of just variables itself. But yeah, let's see. Yeah, perfect, Daniel. Thank you, Daniel. What resources do you recommend? Think as a computer scientist. Thinking as a computer scientist, the computer science itself is really about, you know, like it's the mathematics of, you know, algorithms and, you know, data structures and whatnot. Well, for one, you could probably, you know, take like one of these edX courses, you know, like free courses on the internet, because, you know, it's kind of like mathematics, or it is mathematics. You know, you have to think about it as abstract structures and, you know, yeah, and abstract structures and like relationships and whatnot. So it's same as learning a new math skill. So what really helps is like taking a course helps very, very much. Going to clubs. There's like Python Club, PyYYC, great club. Right, Carson, very good club to go to if you want to learn Python and learning like a little bit more. But yeah, just reading through books. I myself have like I have like, you know, like, I don't know what the Japanese term is, where like you just collect books but really don't read them. I'm definitely one of those guys. I have one of these Art of Computer Programming. You can read that. Very dense, but if you read it, like I'll like to talk to you because you're probably a lot smarter than me. Because I can't read through that. It's very hard. And there's like a lot of like lots of the internet. I'll type what an SICP is very good. You just have to kind of work through it. I've gone through like a third of it. It's very fun, very mind blowing. Very, very good. I'm very sorry. I'm very sorry if I said something. Oh, sorry. Let's see. Let's see what other questions you guys have. Is it something? What? Okay, that's Daniel. How to handle spelling errors? Handle spelling errors, or usually like variable errors would be really on your IDE. I have a this one actually does like a terrible job. This actually does a very terrible job. PyCharm is very good. PyCharm is absolutely incredible in making sure you don't make mistakes. You're still gonna make mistakes, but PyCharm will help you a lot in discovering them at least. So I put like a little document there how to run PyCharm. This is very good. This is a lot better. Like this, you know, this will help you out a lot, and it will, you know, highlight syntax highlight. It will set up everything for you. Yeah, just go through PyCharm. PyCharm will really help you out in there. Okay, let's see. Before you could, okay, yeah, true. Yeah, IDE for sure. Yeah, thanks, Carson. Automated Pro itself, that's a very good book, especially if you're really starting to Python with Python, and you'll realize that Python has a lot of use cases and libraries that help you out in things the boring stuff. You know, it's great. Is there an option to get PyCharm for free? Yes, there is. There is an option to get PyCharm for free, and you can use PyCharm Community. So if you go PyCharm to JetBrains in PyCharm, JetBrains, you go in here, download. You see right here? That's free, my friend. That's free. So you can use that one. if you input spell, yeah, like the for spelling errors, PyCharm actually catches this for you. Like you can go in here. Let's go with my blender. Fahrenheit equals X 5. See right here, it tells me green. Oh, show context errors. It's a typo. Oh, it's a typo. I see. Okay. Fahrenheit doesn't like actually it's somewhere in here, but yeah, it'll tell me it's a typo. Yeah, it's a typo. So yeah, it's definitely PyCharm definitely save you there. I don't know if you guys can see, but yeah, that works out. PyCharm for free. Yeah, but yeah, for sure. Yeah, wait out for that one, Carson.
Okay,
I'll
great,
just have
Daniel.
yeah. I'll just have,
Just before we finish,
Yeah.
I saw a lot of people just turn on their camera, and we're just gonna take a virtual photo for our class before we finish our class today. And great lecture today. It's really fun. It's way more fun compared to when I first learned Python. You guys are really lucky. So I'm just working how, so you stop the sharing. I'm just trying to,
I don't know how to
gallery.
stop it myself,
Okay, great.
unfortunately.
So
Yeah.
right now I have my gallery view, and I see, oh, we still have 60 people. That's great. And if you can turn on your camera, if you don't mind. Great. And if you turn on the gallery view, you can see you follow classmates. That's really cool.
I actually
Great. So thank you guys. So I'm gonna just take a screenshot if that works. So I'm just gonna tell you. Yeah, great. Thank you, Daniel. So I'm gonna see 1, 2, 3, and I'm gonna take the screenshot when I count to 3. So are you guys ready? 1, 2, 3. Great. Thank you. Thank you so much. I think Daniel, sorry, Peter, please stay if you can, if the classmate, the participants has more questions, and if you don't have more questions, you're free to go, and have everyone has a great evening. And thank you so much, Peter, Daniel, Carson, and Daniel Ma for answering questions for today. We're gonna continue our communication and the chat in our snack. So, okay, have a great evening, everybody.
Yeah. I'll stay here for 5 more minutes if you guys have any more questions. Yeah, thank you everybody. Could you just wait other respectable ways other than print to propagate errors back to the call stack? The print, like there's a few let's see, there's a few ways you can do it. There's PDB, which is the debugger, PDB debugger. PyCharm has their own debugger and whatnot. PyCharm has a debugger. But yeah, you're welcome. You're welcome. Cool.
That's good to know. I guess we call it a day.
Yeah. Thanks everybody. Yeah, thanks dudes.
Thank you. So if you folks have any questions, feel free to post it in the section, and we'll be there to answer questions. And I think that's a very successful first session. So thank you all for coming, and thank you, Peter, for this great course. I look forward to seeing you next time.
Great job. Great job.
Thank you. Thank you. All right.
Awesome. This is totally unrelated, folks, but I know that I know that I kind of said this in the chat, but if you do like these things, definitely go to meetups in your city. I know that Carson organizes the PyYYC. I organize Edmonton Pi. I know that the Google Cloud in Edmonton and Calgary have just set up like a lot of really awesome meetups. So if you folks really like these, go to these meetups, and it's been pretty lucrative on finding work and finding like really awesome friends, like, you know, Carson. At least for me, we met through the meetup, and it's just something that I'd highly suggest going to take a look at. So yeah, just as an unrelated note, but great job, Peter. Sorry.
Thank you. Yeah, for sure. Yeah, go to your clubs, guys. Everyone wants people there. Also, when COVID is done, historically, PyYYC gives free food, so it's always good. So you know.
Yeah, so you could turn pizza into code.
There you go. Yay! You feel for that.